Artificial intelligence is the next generation of software engineering. Machine learning models are just like software, but special software. You can't write this kind of software using traditional lines of code. You have to generate it from data.
I think AI will have to come out of the academic experimental world and into the world of software engineering, where we sort of take small pieces of AI and combine them together and put software rigor around it.
I think AI will change pretty much everything around us, from the way we act to the way we feel, the way we think, the way we interact with one another, for better and worse.
I think AI will continue to mature in terms of its process, using techniques like DevOps and MLOps. And this will give us much more trustworthy and repeatable and explainable models.
I think AI will help me improve my fence-building capabilities.
I think AI will help healthcare professionals around the world to make sense of complex medical data.
Enhance our human capabilities, as long as we use it in a conscious and responsible way.
I think artificial intelligence will change our world in fundamental and profound ways. In fact, I believe artificial intelligence will likely be the single biggest technology of our lifetime.
Hello everyone, I'm Shubhangi Shruti, a final year BTech Computer Science undergraduate. I welcome you all to the Global AI On Tour 2020 Bhubaneswar chapter. The Global AI On Tour is a free event organized across the world by the local communities that are passionate about artificial intelligence on Microsoft Azure over 166 locations. The event is centrally managed by the headquarters in Netherlands with the support from Microsoft. Every year, the event brings the perfect balance of quality content, awesome talks, and hands-on learning with like-minded peers around you. With no restrictions, the event mainly surrounds topics like artificial intelligence, Azure machine learning, cognitive services, deep learning, and Microsoft Azure notebooks. The event is organized with the help of the local developer community based in Bhubaneswar, Utkal Techies Forum. Utkal Techies Forum started in December 2016 under the name of Microsoft Dev Community Odisha. It is a technical community in Bhubaneswar, Odisha, which intends to bring together students, developers, professionals under one roof to share their ideas and work for the mutual benefit. UDF started its journey with its first event on 10th of January 2015 at REC Bhubaneswar. This was a beginning to a community that conducted various events at the various venues. On 14 February 2015, an MS Tech session was organized at KIT. The MS Tech Web and Mobile Workshop was conducted at CET Bhubaneswar. Cloud Roadshow, funded by Microsoft, was conducted at Hotel Sheetal. Further events conducted by UTF includes Cloud Roadshow with Abhishek from Kolkata, MVC Workshop with Mr. Harshvardhan on 26 May 2015, sponsored by SoftNet Technoware. UTF was invited at the Electrifying 2015 in KIT on October 10, 2015. The two-chord project MVP was chosen from Odisha in 2016. The techies from the community continued computer awareness program at Patrapada, Bhubaneswar, and an orphanage, Prativa Ashram in Bhubaneswar. The first meetup of UTF was in 2016 under the name of Microsoft Dev Community, MSDC. The journey of these successful events was further taken forward with the Global Azure Bootcamp Bhubaneswar 2016, and the other events were conducted under the name of MSDC during the weekends at the different venues. Session on .NET Core was delivered by Mr. Tadit Das, the co-founder of Utkal Techies Forum. An IoT Insights and Opportunities session was given by Durga Charan Ojha, powering IoT apps with MQTT at USBM on 20th August. Further, there was a deep dive into 8051 microcontrollers with the introduction of Arduino, which is an open source hardware, software, and content platform worldwide community with over 30 million active users. On January 7th, 2017, the Bhubaneswar chapter meetup with the theme of cybersecurity was conducted, with the other community events being conducted during the weekends. Utkal Techies Forum was recognized for its community activities by Arduino official community in 2017. UTF conducted a session on getting started with Alibaba Cloud MVP Tech Show on 25th August 2018 at KIT TBI. A webinar on JavaScript prototypes on December 7th, 2019, and introduction to RabbitMQ on 19 December 2019. A webinar on mobile development using Flutter on 28 December 2019. The UTF Horizon 2020 on 1st February 2020. UTF has conducted various events during the pandemic, including the UTF Students Doubt Clearing class, OOPS and Solid Principles on 26 April 2020, OAuth 2.0, OpenID Connect, and JWT Token on 30th May 2020. Session on improved query performance using indexing and caching, going serverless with Azure, and going serverless with Azure Functions. Moving forward, I would like to invite the co-founder of Utkal Techies Forum, Mr. Tarit Dash, for sharing his takeaways and journey.
Hi, Subhangi. Am I audible? Yeah, hi everyone. Good afternoon. Subhangi has compiled a lot of stuff, taking it from different forums like Facebook, Twitter, and then taking it from me and then other members. So I welcome all of you to this world-class event we are doing today is Global AI Tour. And So she has already talked about the community a lot, but let me just tell something else. When we started, as Subhangi said, actually we were 4 or 5 people. We went to a coffee shop and then we talked about different stuff here and there. We talked about how we can gather these techies together in Bhubaneswar in Odisha, and how we can talk about technology and how can we grow together in this community. So then we got this ideas that we should start something, and then people would join, and then we can share our knowledge. So the baby came out of that talk was Microsoft Dev community at that point, and then we started different events, going to orphanages, schools, then hotels, and we started with quiz contest, as Subhangi said, in my college, because it was easy to get that venue, because I belonged to that college when I passed out from BTech. So apart from all these events, actually we have a group in WhatsApp where there are a lot of student and software techies are there. So the benefit of having that group is you have diversified technical expertise, and whenever you ask any question, you are stuck at some point, somebody would jump in and help you in that. Then I know personally there are some people from startups who are in that group, and then we're getting people to work with them as well. So we have achieved that goal, that we together created that ecosystem where people can talk and brainstorm their ideas. That is also done. We are moving in right direction with new leaders coming up like Asirbad, then Tanmay and Subhangi, of course, for this event, and she's going to do a lot in the future. So we are encouraging these young leaders because we are so occupied and we are not able to deliver right now with this pandemic situation and work from home options. So these students and these youngsters are coming. Like, I'm also young, I'm not an old man, but still these people are doing a great job in organizing this event, especially Global AI Tour. So Yeah, that's it from my side. Apart from that, yeah, I would definitely say this, that personally we have leaders in the community who are actually mentoring one-to-one as well to a few students. I have personally went to different colleges and also joined some events with hackathons and everything. So yeah, that was how we started and how we grew together with the community, with the students and techies with us. Yeah, Subangi.
Thank you, sir. Thank you for sharing your thoughts with us. Moving forward, our event, we shall now discuss about the sessions for the day. Presenting to you the agenda for the event. Our first session shall be taken on how to perform data science analysis using Elyra, and it shall be taken by Yiwen Li. Yiwen Li is a developer advocate and a data scientist at IBM, where she designs and develops data science solutions and machine learning models to solve real-world problems. She has been creating online content such as code patterns, tutorials, and blogs demonstrating the potential of products and services offered by IBM, like Watson Studio, machine learning, model asset, exchange, data asset exchange, etc. She holds a dual degree in BS in probability and statistics and BA in economics from the University of California, San Diego. Have you ever wanted to run multiple notebooks in sequential and parallel order with one click? If so, then you must join our Intro to Elyra, an AI-centric extension for the Jupyter Lab session to learn how you can get up and running with Elyra. This workshop introduces users on how to run data science notebooks with Elyra, an AI-centric extension for Jupyter Lab. The notebook pipeline downloads a free data set from the data asset exchange and then extracts and cleans and analyzes the data file. The cleaned data file is subsequently used to predict certain weather features. Do no harm, a checklist for responsible AI. It shall be given by Priyansha Mishra. As a technology strategist to Microsoft partners, Priyansha is bringing digital ambitions to life by helping them empower their employees, engage their customers, optimize their operations, and transform their products. She is also a passionate driver for Microsoft's AI country plan, contributing to closing the skills gap and enhancing employability in AI. The session will cover the guiding principles of responsible AI and showcase demos of the tools and technology Microsoft offers to put these principles into action. This will be a detailed technical discussion with demos and is intended to be an L300 and L400 session. Our third session is on leveraging AutoML to fit your needs by Akanksha Malik. Akanksha is a data scientist at Telstra Purple, a Microsoft AI MVP and an international speaker. After studying financial maths and actuarial science at UCC Ireland, she realized she wanted to work with people as well as numbers. At Purple, she is working with the clients to help them solve problems by making more informed decisions with data. She is a firm believer in diversity and inclusivity. She loves machine learning, and that is becoming more accessible to everyone. She is an avid advocate for women in STEM and is currently the network director of Women Who Code Melbourne. AutoML has automated the time-consuming iterative tasks of machine learning module development. It allows data scientists, analysts, and developers to build ML models with high-scale efficiency and productivity, all while sustaining model quality. Created as a no-code environment, it makes these new advances in AI more readable, readily available, and accessible to everyone. We will be going through an end-to-end demo on how to create and use a solution on AutoML using the UI as well as a more manual approach. Whether you need quick prototyping, machine learning without the coding, or just a method to decrease experimentation time, AutoML has it all. The drag and drop chatbot development using bot framework composer session shall be taken by Jamie. He is a software architect, developer, Microsoft MVP, and a Pluralsight author. He's a lifelong tech enthusiast with over 20 years of professional experience. In the session, attendees will learn about bot framework composer and how this can be used to build chatbots. The machine learning in browser with tensorflow.js shall be taken by Håkan. Håkan holds a Master of Science degree in electrical engineering, and besides, he holds a master's degree in leadership and organizational behavior. He has also taken courses on university level in psychology, interaction design, and human-computer interaction. He has 20 years experience of software development in various positions such as developer, tester, architect, project manager, scrum master, practice manager, and team lead. Håkan is the chairman of local chapter of Norwegian .NET user Oslo and is an active ambassador of Oslo. AI, the local chapter for Global City AI community. Besides, he is the co-founder of AI42, an online school for learning about AI and data science. Håkan is a Microsoft Most Valuable Professional, MVP, in AI. Currently, Håkan is working as Manager AI and Big Data in Miles AS, a Norwegian consultancy company. To start with machine learning, you typically would need to learn Python, TensorFlow, Jupyter Notebook, etc. But if we could run our machine learning straight in the browser, this can be done through tensorflow.js. In this session, you will get an introduction so that you can use it in your projects. Intro to machine learning using tensorflow.js, image classification using MobileNet, making a web application, and image classification demo are the things that shall be covered in this session. Our last session on Azure Custom Vision in Action shall be taken by Goran. Goran works as a technical manager for StratiQ. He is a Microsoft AI MVP. He has 15 years of work experience in IT and wide knowledge about various technologies and programming languages. He worked on various projects for notable clients and projects. His work have been featured many times on websites like Forbes, The Next Web, NVIDIA Developer, The Guardian, The Verge, Macworld, and others. In the last few years, he attended several hackathons and other competitions on which his skills and work were recognized and awarded. Goran is a tech enthusiast. He writes technical blogs, posts, and he likes to share his wide knowledge of different workshops and talks. The Azure Custom Vision service is optimized to quickly recognize major differences between images. So you can start prototyping your model with a small amount of data. In this workshop, you will learn how to use Azure Custom Vision and how to build simple web applications with it. You will be able to see how to prepare the tag images for model training, train custom model for classification and object detection, test, improve, and publish the model, take the images from the camera and process them via JavaScript. We are extremely grateful to our sponsors, Pact and Microsoft, for this event. Founded in 2004, Pact is an online library and learning platform for professional developers. Pact aims to help the world put software to work in the new ways through the delivery of effective learning and information services to the IT professionals. We are happy to announce that Pact is providing a 20% discount on the following 4 books that you can see on your screen for all the attendees who have registered themselves for our event, the Global AI On Tour 2020 Bhubaneswar chapter. Mastering Azure Machine Learning, Deep Learning with TensorFlow 2 and Keras, 2nd edition, Deep Learning for Beginners, Python Machine Learning, 3rd edition. The vouchers for the same shall be delivered to the attendees through the mail. Additionally, Pact shall be providing a free ebook to the person who asks the best and the most interesting question to our speakers during the session, which shall also be shared in the mail. Microsoft Azure, commonly referred to as Azure, announced in October 2008. The Azure Cognitive Services brings AI within the reach of every developer without requiring the machine learning expertise. Microsoft has announced to provide vouchers to the top 5 scorers of the quiz. You can find the link to the quiz in the description box, or you can scan the QR on your screen. These role-based certification vouchers are valid in India for the roles-based exams as well as for the 70, 74 and MBX series exams by Azure, but shall not be valid for the AZ900 certification, which is the fundamental certification. The quiz shall not be accepting responses after 8:30 p.m. today, so it is recommended you must attempt the quiz as soon as possible. We also have this cool opportunity from Microsoft Learn, wherein if you complete any one of the module from the 8 given modules that have been generated for Global AI On Tour session, and you share the screenshot of the badges from the achievement section of your profile on Twitter using Global AI On Tour BBSR and tagging Vivek Sridhar and Aurokshit Saha, you can get a chance of winning a hero badge from Microsoft Learn that you can share anywhere on your social media platform once they reach out to you. The link for this module is provided in the description box. Let's check how can we get that. So these are the 8 modules that have been generated for Global AI On Tour attendees. You first need to sign in. I shall be using my sign-in account. And you need to complete any one of these 8 modules. After completing this, under the profile section, you shall find your achievements, wherein you can see the batches. You need to take this screenshot and share it to Twitter so that you can, using the hashtag Global AI On Tour, and by tagging Vivek Sridhar and Aurokshit Saha so that they can reach out to you. And you can win a hero badge from Microsoft Learn. So we are ready to begin with our sessions. We hope that you are excited for the same. I would like to invite our first speaker, okay, before inviting our first speaker, we would like to hear a few words from Tadit sir before beginning our session.
Yeah, so before starting the session, I wanted to motivate few students who have already joined this YouTube stream. I want to look forward to the students that they're doing a lot of job in this IT field, and they're into multiple things. Like they want to do something in AI, artificial intelligence, then they want to do something in machine learning. But what comes to the end is, are you good at the basics? So I would suggest every student over here who are listening to this particular stream to go to your books. Those are suggested in your syllabus. Go through them, or if you don't find it useful, then go through other books. Don't leave your books, even if you watch videos and articles, blogs, etc. on your laptop. But having a physical book in your hand and reading that is very much useful, and it will help you in the long run. Always focus on the basics like OOPS concepts. If you want to go into the software field, then OOPS concept, database concepts, all these things are really necessary, and it would able to help you to crack these interviews. So I think, yeah, that's it. That is something which I always give advice to the students. So for that reason, I wanted to say this to the students over here. Yeah, I think Subhangi, I'm good. Let's start.
Thank you, sir, for this motivation. Now, I would like to invite our first speaker, Yiwen Li, for the session How to Perform Data Science Analysis Using Elyra. Over to you, Yiwen.
Thank you so much. Can you hear me now? Okay, so 1 second. I'm going to share my screen right now. IBM Codec team. Sorry, I think there's some issue to share the screen. Just 1 more second. Sorry about that. Elyra, and AI-centric extensions to Jupyter Lab. My name is Yiwen, and today I have my colleague here, Edward and Sashruti. So before we get started, I want to give you a brief intro of us and what's our day-to-day job look like. I'm a data scientist and I'm part of the Codate team. My day-to-day job is to create machine learning and data science use cases using our data sets. Over to you, Edward.
Hey everybody, my name is Ed and I'm also a data scientist on the Codate team. I work on a few of our projects here at Codate, including the Data Asset Exchange and the Model Asset Exchange.
Hello everyone, I'm Sashruti Swaminathan and I work as a developer advocate and data scientist in Codate team. And thanks for joining us today.
So just quickly, before we dive into the rest of our talk, I wanted to give you all a brief overview of everything that our talk will cover today. So first, Sashruti is going to give you a short summary of the many projects we work on here at Codate. Next, Sashruti will go on and give a deep dive into one of the two Codate projects that we are showcasing for you today, and that is DAX, our Data Asset Exchange. Then I will introduce you to our second project, Elyra, which is a suite of AI-centric extensions for Jupyter Lab. Finally, Yiwen will give a demo showcasing how you can combine both of these projects, DAX and Elyra, to produce an effective and efficient AI workflow. And at the end of the talk, we'll also leave you with a few resources to get you started and up and running with DAX and Elyra.
Hello everyone. Now let's have a quick look at the Codate team goals and projects. Codate stands for Center for Open Source Data and AI Technologies. We are 30 plus developers and data scientists headquartered in San Francisco and distributed around the world, working towards contributing to open source projects. We contribute to both in-house as well as external open source projects and cover entire data science pipeline. As you can see in the image, we have projects that can help you in gathering your data till maintaining your model. So to connect artificial intelligence solutions to real world problem, you need people who can understand both AI and the problems you are applying it to. So in many industries, the only way to assemble both AI skills and industrial domain knowledge is to have a large cross-disciplinary team. And this fact makes it expensive, and it is also risky to deploy artificial intelligence application because you need someone with a business knowledge as well as AI knowledge to maintain it. So what is our mission here? So our mission is to address this problem by democratizing AI, which is to make AI technologies accessible to the practitioners that understand real world problems so that they themselves can develop AI solutions that can solve their business problem. So DAX offers high quality vetted data. By vetted, I mean we start by tracing the origin and merit of the dataset, learn about the usability rights and ownership. From here, we create standard metadata and perform internal legal review before releasing the dataset. And these datasets have clearly defined open data license, and we provide exclusive access to IBM research datasets that have played crucial role in building popular AI systems like AI Debater, entity recognition, and so on. Each dataset comes with tutorials that demonstrates the usage of data, and these tutorials can be directly exported as Watson Studio notebook or project. Next thing, we also provide data glossary to learn more about the attributes of the dataset, an option to preview the data to help users understand the data before using them. This will give them an overview of the data that they are planning to use in their application. Also, industrial use cases. We have created industrial use cases using the DAX datasets, and they are available as Cloud Pak for Data Industrial Accelerator. And you can directly take these accelerator and plug into your or use it in Cloud Pak for Data. I have listed all the resources in the slides that you can refer to and know more about it. So this is our DAX page. If you click on Learn More, you will have a detailed tutorial of what is DAX and what we provide as a part of this project. So if you want to know more about, the recent launches, like if you want to know about, the recent releases, what we have added new, you can get into the what's new page. And if you want to connect with us, you can click on get involved, and it'll take you to this repository. You can start creating issues here and being one of our team members, and we'll be there to help you with your questions. So now I'm going to demonstrate to you all these features using two of our datasets. One is the PubLearnet dataset, which is one of our popular IBM research dataset. So first, let's see about the landing page. So this is the dataset. If you click on the tile, it will take you to the dataset landing page. The dataset landing page has a detailed and structured information about the data. First is the overview section. This overview section walks us through the dataset, what it is, right? What this dataset is about. So that information you can find under this overview section. Now let's get into the dataset metadata. Metadata section has details such as format, license, which domain does this dataset belong to, and how many data points we have. And let's say in your data, you have them in different split, like a split for training your data, the split for validating and testing your data. So how many data points you have under each split. So those kind of information you can readily get from this metadata section. And you have information about the author, origin, and data coverage. Origin is nothing but where the data set is from, and data coverage is more about which areas in the specific domain does this data set cover. Also, we will end up with a business use case. So each data set is available in archive file. You can just click on get this data set to download the data set, and it's in archive format, it's in tar format, which you can untar and extract the contents. So the next I would like to demonstrate the data glossary and preview. So we have the button here, try the data set, try the data and notebooks. So you have the same metadata details here. So this is the preview page. We have previews tailored towards dataset format. This one is an example of image dataset, right? So we have provided a way for users to get a feel of how the dataset will look like. Here you have one of the images in the dataset with its related annotation. So on the left side, you have the image, and on the right side, you have the annotation. When you take this annotation and overlay on the image, which you are seeing on the left side, you will get the middle image, which is the annotated image. So the annotated image, you get it using the notebook. So if you want to know a way for visualizing this annotation, we have the notebook preview option here. So this notebook preview option, if you click on the notebook preview, it has instructions to download and extract the dataset and visualizing the data and to create models and so on. Now coming to dataset glossary. To understand your data better, we have provided data glossary, which is a list of terms with their definitions. Here, for example, you have images. So what this image contains, right? You have annotation, and you have different types of annotations, right? So if you want to know more about each term, know more about the know the correct description or the definition of the term, you get into the dataset glossary page. So as I've mentioned before, each dataset has assets associated with it. Asset can be either a notebook or a Watson Studio project. In this example, it's a notebook. So if you click on try this notebook, it will provide you an option for directly using this notebook under one of your existing Watson Studio project, or you can create a Watson Studio project and add this notebook to it. We also have some examples. If you see in our page, this is NOAA weather data. And if you click on run the dataset notebook, they're already available as Watson Studio project. So you can directly create a project here, and all the assets are already into it. So you can directly start using it. Cloudpack for Data is a fully integrated data and AI platform that helps modernize the way you collect, organize, and analyze data to infuse in artificial intelligence applications. We would like our users to know how these datasets can be used in solving a business problem, not just stop with model development, right? So we call these assets as industrial accelerator and can be directly used inside Cloudpack for Data. So one example is this agriculture accelerator that I'm going to show. So it's loading. Yes. So the use case here is to monitor crop growth. Let me maximize it. Is to monitor the crop growth using a crop guide, which you're seeing here. And it provides timely alert to farmers about the weather change, possible development of crop diseases. You can see the list of disease here, evaporation of fungicide, and efficient use of solar panels, which is agrivoltaic support. This is basically a Shiny app. It is developed in Art Studio, and you can directly deploy this app and use it as a starter application. So this is one of the example of accelerator. We just don't want people, to just stop with the model development. We want them to actually know where they can use this data sets in solving a business problem. So yes, I have covered this part. So I hope you all enjoyed this DAX part, and over to Ed for Elyra part. Thanks, everyone.
Thanks, Ashruti. So let's now dive into Elyra. At its core, Elyra is a set of extensions for JupyterLab catered to people who like to work with artificial intelligence and machine learning using notebooks. Elyra's goal is to help data scientists, machine learning engineers, and software developers through the most common model development lifecycle complexities. If you'd like to access the GitHub repo or the docs for Elyra, you can follow the links we've shared here on the screen. Elyra was officially announced as an open source project by IBM this past April. Elyra boasts a host of features to achieve its goal, which we'll discuss shortly. For now, notice from the preview Elyra's UI on the right here that Elyra doesn't radically reinvent JupyterLab to provide you with all of its enhanced functionalities. It simply extends the distinct JupyterLab environment that we've all come to know and love over the years with added tabs, toolbars, and launchers. So what can Elyra actually do for you? Well, you can really break down Elyra's core features into 5 items. The first, Elyra provides an easy-to-use notebook pipeline visual editor. Why build your next AI model using a pipeline editor? Well, it's because Elyra provides a simple visual way to convert multiple notebooks covering pre-processing steps, experimentation, optimization, and deployment all into batch jobs or workflows. Second, Elyra supports running notebooks as batch jobs directly in the UI, making model training easier. Third, Elyra supports easy creation and insertion of reusable code snippets. This allows users to manipulate reusable pieces of code, making programming in JupyterLab more efficient by reducing repetitive work. Fourth, Elyra pipelines support Git version control, allowing rollbacks to working versions of the code, backups, and most importantly, sharing amongst team members. And fifth and finally, Elyra exposes Python scripts as first-class citizens. This allows users to locally edit their scripts and execute them against local or cloud-based resources seamlessly. Yiwen will now demonstrate all of these features for you in our demo.
Thanks, Ed, for the overview of basic functions of Elyra. So before I go into a live demo, I want to introduce you what is a pipeline. So a data science pipeline usually includes 5 steps, from data extraction to result interpretations. And let's think of this with a simplest example, such as a Python script. What you do is you typically read in some data, do something with the data, for example, machine learning or deep learning models, and then push the stuff you want to keep to a file system, or save it, or output the files. and then run this on a scheduler or somewhere else. Elyra makes it possible to run Python notebooks instead. I mean, why running Python scripts when the Jupyter notebooks are so much easier? Usually, the notebooks make things a lot easier to understand, it's more intuitive, and have each component to run together continuously and iteratively. It means you can always come back and go forward, you can delete some cells, and do whatever you want. It also makes it easier to tell the story behind the pipeline. And it might grow bigger as a project. You can think of this as a novel. In that case, we would like to break them down into smaller chapters, basically easier to maintain in the long run as well. It also brings in a benefit that if your notebook doesn't have dependencies on the prior notebook, it means you can run them parallel, or you can run them sequentially. Some notebooks might have different requirements than the others, like libraries, framework, file dependencies, environment configurations, etc. We want to make the pipeline eventually portable and shareable, so we need to take these factors into account. And we need to configure these for each notebook separately. We can run Elyra in containers, such as Kubernetes, and this will save time and save memories and GPUs because you can run things parallel. And workers can have different hardware configurations to accommodate various workloads. Clusters can also scale up or down, depends on your resource need. Also, if you need to change anything in one notebook, you don't have to rerun the other notebooks by clicking them through. Elyra will save your efforts by constructing them as a pipeline and run them all with one click. So now let's go into a live demo and let me show you how to run this. Also, there are several prereqs to run, so before we get started with Elyra, please check on the list, see if you have everything installed. Also, I copy-paste a few easy code snips in here. To install Elyra, you can run this in your local machine on your terminal, and also you can verify the installations. And after everything is complete, you can start the Elyra by running Jupyter Lab. And also feel free to check out the code on Elyra GitHub repo to clone, to fork, and also you can check out on the Elyra documentations. Okay, let's get into a demo. Now, let me walk you through a demo by running 4 notebooks using Elyra. I will introduce you 2 ways to run your pipeline, both on local machine and on Kubeflow pipelines. To build a pipeline, you can simply drag and drop the notebooks onto the canvas and then connect them, just as easy as drawing a graph. You can arrange the notebooks in sequential or parallel order. You need to configure notebook properties for several informations. We put the environment variable dataset URL as a dataset download link from DAX. We copy-paste the link into a section. This notebook produced output files, so I specify the file name as gfkweather.csv, which is downloaded through the first notebook into the directory. The output files are uploaded to the cloud storage or saved in local directory after a notebook processing complete. We also need to select a Docker image that will be used to run the notebook. You can bring your own image or choose from the predefined public images. We choose pandas as a Docker image here because we mainly use pandas and NumPy packages in the notebooks. We could only select one Docker image each time. However, if you're running on your local machine, the image you choose does not matter. Also, you can declare the file dependencies as gfkweatherclient.csv, but this is not necessary since files are already in the same folder. I redefine the name of the pipeline by right-clicking my trackpad, changing the name to event.pipeline. Also, you can add comments to provide short descriptions. This helps your colleagues know the function of each node before going into it. Now, everything is all set. Let's save the pipeline and submit it to run locally. The running logs are shown in terminal. If everything completes successfully, a message will pop up. The run outputs will be shown in the notebook cells. See on the left side, the notebooks are just updated a few seconds ago. Now, Let me quickly walk through the content of each notebook. Firstly, the load data notebook downloads, extract the zip file through the dataset URL link, and save it as a JFK weather.csv file. The Part 1 notebook loads the dataset downloaded from the previous notebook, replace the wrong values such as none, t, 0.02, 0.01 second, filter out everything out of the range, converts columns to numerical types, clears out missing values, renames the columns, and then save the clean dataset as JFK weather clean.csv file. The Part 2 notebooks select the 5 columns from the clean data and visualize the trend. Also, it explores the dependencies between the 5 columns. Then it visualized the trend of the rolling average in 2017. In the Part 3 notebooks, this explores the approaches to predict future temperatures by using the time series dataset. It creates training, validation, and test split, and then it trains the dataset and then compares the performance between different baseline models using the mean squared error. And it built a RIMA model predictions for the first 48 hours of the validation set. You can get the notebook on DAX page. By clicking on Preview Notebooks, you can see we have 3 notebooks very similar to what we have in demo pipeline. The notebooks were designed to run on Watson Studio and IBM Cloud. I made minor changes to the notebooks to fit this into the Jupyter environment. Now, let's submit and run this pipeline on Kubeflow. Before running, you need to configure a runtime by putting your credentials into each section. I already pre-configured my runtime, so now let's submit the pipeline on Kubeflow. In the run process, Elyra generates, gathers, and packages the required artifacts, upload them to cloud storage, and triggers pipeline execution in the selected Kubeflow pipeline environment. The pipeline runs are listed in the experiments panel. The graph panel displays the execution status of each node. You can see the Part 1 notebook is completed and has green checkmark at the right top. After the run is complete, you can access the pipeline's output artifacts using any supported S3 client. In here, we have all input and output files listed. Clicking on the data folder, which includes the JFK data file and the clean version. All tarballs are input files. By clicking on one of the output files and download, you can see the result of the notebook is saved in the output cells. So if you want to get involved with Elyra, please visit our GitHub repo and open enhancement requests or bug reports. Also, I copy-paste a few related links to our talk today, and feel free to check the bit.ly pyjamas-Elyra. We have our for the question, I see there's a question in the channel. It's asking, in data science process, there are lots of tasks in the pipelines. Would you please tell us which task takes the most time? Okay, I'm gonna share my screen right now. So I wanna ask, so is your question about this notebook in particular, the one I was showing in the demo? If that's your question, so it really depends. So for this one, okay, definitely the Part 3, because this is building a model in the Part 3. If for something more complicated like machine learning or deep learning models, it takes time to train, especially for the validation set. Like you have 10, for example, 10 folds that you have to go through. So it means it will take longer time. Hopefully that answers your questions. Another question is, while performing any machine learning task, we might require various libraries and dependencies. Is it going to be a tedious step in Elyra for downloading and importing them? Okay, so to answer this question, if you're just running this pipeline locally. You don't have to configure this because everything is in the folder already. Like I'm doing this because I also showed to submit this to run on Kubeflow, which is like you have to get everything ready because this is how they're gonna read the files in the folder. But if you already have those in your local machine, you're good to go. You don't have to do everything. Especially for the runtime image, you don't need to configure this. This is pretty much for when you want to run this on Kubeflow. So while nobody's asking the question for now, I'm gonna talk about something else that might relate it to data science. I think that's also very helpful for you to learn as an engineer. So, okay, let me share my screen. Okay, somebody also asked a question, which is more important to you, model accuracy or model performance? I think this is like a balance because sometimes it will always have the overfitting issue as well. If you are just asking for more accuracy, it will overfit. So it really takes a balance. Like you have to look into the AOC curve and also the recall curve. So you have a balance between them, but it really depends case by case. So this is basically the link I just showed in the previous when I was talking about the DAX. So I found out there's something really interesting. So today I just talk about the NOAA weather data JFK airport. This is in the demo. And also there's something else you might gonna find. So maybe Fashemness. Maybe everybody have heard of it, if or a lot of people heard of it. So I wrote a few notebooks related to this. Okay, I'm gonna click on preview the data in notebooks. So it will firstly give you an idea about how the data look like. Also give you like how the data glossary look like. For example, like how each columns, what does it mean, and how you can do with it. So the important part I want to show you is that if you click on notebook preview, it will tell you like, oh, this is how you can run the notebook, right? So if so I think all of the data science process can be replicated because like how you process a notebook, how you process the data, like for a pixel, for a picture, how do you do with it? It's not only about that picture. It's not only about that data set. So whatever I do in the for one of the data set can be also applied to the others. So this is like something really interesting to me, and also for tutorial basis and also educational ideas. And also I put some machine learning, deep learning models here. This is has more well-built visualizations and models than the one I just showed in the demo. If you want to check out more about data science process and how you can build an accuracy curve or how to compare the validations, how do you balance between them, this is very like it has a lot of detail here. Whatever I wrote in the code, I also explain a lot. So this might be a good resource for you if you want to check it out. So yeah, just want to mention this. So if you want to run this, maybe I think there's no function to download here, but if you want to run this, you can click on Run the Dataset Notebooks. It will take you to this page. From here, you can download and do whatever you want. So another question, can Elyra only used for classical ML models, or so for this question, definitely for everything. So Elyra is just an extension. You can do whatever you want with it. So for example, right now I'm doing this like pipeline editor. I click on it. So if you have this installed, you will have this this section here, Elyra, give you 3 choices. If you click on the pipeline editor, it will take you here. And at the beginning, it should be empty. So for example, I just want to run this one. I just want to run this notebook. Or I just want to run something else. Or you can just run a Python script. On the left side here, there's a lot of functions. There's one function says code snips. If I just want to run this, I can also just do that. It doesn't have to be a Jupyter notebook. So whatever you write in a Jupyter notebook should be fine. It wouldn't affect anything. Hopefully that answers your question.
Hi, Yiwen. That was a great session and you were so open to the question. Thank you so much for this wonderful session.
Yeah, thank you. Hopefully this is helpful, and let me know if any other question come up, and feel free to shoot me an email or connect with me on LinkedIn for more questions. And also we are open source, so whatever issues or enhancement you found, you can go to Elyra GitHub repo, open issues, requests, whatever. So we are really open to that.
I'm sure our attendees after trying Elyra will definitely reach out to you. Thank you so much for everything.
Thank you so much. Yeah.
So next, I would like to call Priyansha Mishra for the session Do No Harm, a checklist for responsible AI.
Hey, hi, a very good afternoon to everyone attending this session here. Welcome to my session on Do No Harm, a checklist for responsible AI. Today, I will be talking about some of the things that can help you build AI technologies responsibly. That will range everywhere from principles to practices to tools. Let me start off by actually introducing myself. I'm Priyansha Mishra, a partner technology strategist at Microsoft India. And like I said, I want to just start off this session with sharing my screen, and let me know if you can see it. Maybe the producers can help me out here. I hope all's good, and I'll start off. Okay, I'm assuming that's a yes. All right. So starting off, I think I really want to start off by really discussing why are we talking about responsible AI in the first place? What makes AI so different from other technologies? That responsible AI is a central conversations anytime we're talking about building AI technologies. Now, if you talk about AI, advancements in AI are really different than other technologies because of the pace of innovation, number one, and its proximity to human intelligence, which can impact us at a personal and societal level and gives AI the power to do a lot of both harm and good. So in that sense, like my session says, do no harm. That's what we intend to do by starting this conversation around responsible AI. And this is exactly why we must be having this conversation as a central piece to the larger problems that we're trying to solve with AI. So if you see on the screen, this is exactly what I'm trying to say by the pace of innovation that we've seen over the last couple of years, where in 2016 we've seen object recognition come in human parity, and 2017 it was speech recognition, 2018 on reading comprehension, and so on. So the pace of innovation is definitely different, and definitely it is the proximity to human intelligence is really making it a topic of great conversation around the responsibility and ethical use of this technology. Now, if you look at this particular report, this also reinstates the fact that this must be a central conversation, and this not just in principle that we're talking about ethical issues in AI, but this is very much practical now, where we're seeing nearly 9 in 10 organizations across countries encountering ethical issues resulting from the use of AI. So you will see the overall average coming as 86%, and in India itself, we have 85% of the leaders, talking about the issues from the use and implementation of AI systems. Now, moving on, I think. Hello. Am I audible? Hello. I think I'm having some issues with echo. Let me present my screen again. Apologies. Okay. All right. So what I wanted to talk about in this particular side is the progression of responsible AI. So from a Microsoft standpoint, this whole journey started in 2016 when Satya Nadella outlined the core set of principles around responsible AI, which are the 6 principles that you see on your screen. And from then on, we've taken it all the way from principles into practice. Right. So now Microsoft is really working to make that a little more holistic, with principles, practices, and tools coming into play to make sure that it's not just it's not just principles that we're talking about, and it's not just theoretical, but it is something that actually developers and data scientists can put into practice. So with that, let me actually start off with what forms the foundation of this whole conversation, which are the principles, following which the practices and tools will also be covered, and that's where you take those principles and take the foundation in all the way into action. So if you look at the principle, these are the core 6 set of principles that we have outlined, and I'll go deeper into each one of them. So starting off with fairness. Now, if you look at fairness, really we live in an unfair society, right? Our society in general is an unfair society, but what we want from AI systems is to make sure that it's either reducing that unfairness rather than keeping it at the same level or making it worse, right? So that's what we're trying to get AI systems to do at the core. And also because you see that AI systems right now are being used in a lot of scenarios to allocate or withhold information or resources and even opportunities, like for example loan or job applications. So we've seen a lot of use cases around AI being used for the first set of screening around maybe a loan application, job application, credit card defaulters. So in that sense, we want to make sure that all similarly situated groups in this case are treated fairly. By that, let me take an example. We actually personally know a couple, husband and a wife, who applied for a loan, right? And they applied for the loan separately as 2 different individuals with very similar backgrounds, very similar credit scores, very similar financial status and everything. But one of theirs got rejected and one of theirs got accepted, right? So really, if you look at it, the fairness in this system was a little hard to decode as to why that happened. And it may seem like sometimes these AI systems may be reinstating some of our societal bias, right? So whatever is the societal bias that is already there in our unfair society, that should not get reinforced into our AI system. And that's what we mean when we talk about fairness. Now, if I take up the next one, which is on transparency. And this is so important for three very key things around AI. One is to build trust with users. Now, this is a time of tech alarmism. I mean, I'm sure you all have seen a bunch of these documentaries that have come out in the recent past and read in the news of how there is an increased alarmism around AI, around technology. And with that, there is a need to build trust with our users. And that's what transparency in AI systems can help do. The number two thing is on debugging for developers. I mean, developers need to understand how their AI systems are built, what are they actually trying to do to make sure they're effectively able to debug. And also, third is to mitigate unfairness. We talked about fairness in the last principle, but to mitigate that, we really need to understand what is it that our AI system is really trying to do, how transparent it is, and what are we really trying to achieve with it. The third one is on accountability. Now, if you talk about accountability, I mean, we've talked about a bunch of issues around AI, but at the same time, at the end of the day, the creators of AI must be accountable for the technologies that they build. In that sense, it is even more important when it's a sensitive use case like a facial recognition technology. Now, I'm sure you must have seen in the news of how Microsoft is really advocating for regulation of facial recognition. While facial recognition can have a lot of great use cases in governance, at the same time there is that risk of not maintaining a user's privacy or having continuous surveillance on a person. So in that sense, we've advocated publicly a lot for the surveillance of the same, for the regulation of the same. And in sensitive use cases like this, there is a lot of accountability that must be in the system when we talk about AI. The next one is around inclusiveness. So when we talk about inclusiveness, really, it while we can design for the larger masses, it is really it really makes a difference when we design for that 3% of the population that can cater to the 97% as well. When we say that we want to empower everyone on the organization with AI systems, we don't want to leave anyone out, right? So it is to build an inclusive AI system and make sure that our AI systems are inclusive by design. And we're thinking of inclusivity right from the initial phase, and it is not coming as an afterthought. Inclusiveness can come in various forms, but maybe let me take an example of the kind of AI that we're bringing to our office products. If you see what we have in the PowerPoint, right? Accessibility checks. We have in Teams, Microsoft Teams, if we're doing meetings, we have those speech to text conversions and a lot of other features that make sure that meetings are accessible, meetings are inclusive, and that's really central to how any AI system must be built, and that really forms a key pillar of the core set of pillars of the responsible AI charter. The next one is around privacy and security. Now, in this sense, if you look at it in today's age, privacy and security is really central to any technology system right now, right? But even more so with AI because of its dependency on data. Now, if you look at this, there are three things that you must think about when you're thinking about privacy and security from an AI standpoint. And one is on the data origin and lineage. That is basically where your data is really coming from. Second is on the data use, whether it's external, internal, is it user submitted data? Are you getting it from some public forum? And the third is around data corruption. Has the data been, modified in certain ways to influence decision? So, deploying systems like anomaly detection to make sure that the data is not corrupted and, decisions are not being influenced because of that. So that forms the next pillar around privacy and security. And finally, on reliability and safety. Now, when you talk about reliability and safety, again, this is very, very critical to make sure that we build trust with users, because we must be able to understand, even if our AI systems are making mistakes, we should be able to understand in what ways and it can go wrong, and what are the limitations of the AI system, and what can sort of be the quantifiable way to understand the reliability and safety quotient of an AI system. In that sense, in a lot of systems, this is very critical. Let me take the example of a self-driving car, for example, where reliability and safety is absolutely critical. The second would be around a healthcare system, right, where AI is being used for diagnosis or in various other settings in the healthcare system. So in that sense, reliability and safety again is a very crucial part of the AI system principles and the responsible AI principles. So with that, those are the 6 broader principles that I wanted to talk about before even initiating the conversation around practices and tools and what else we can do with it. But these really form the foundation of that entire conversation. So that was the principles. Now I also want to talk about the practices that we have outlined to make sure that all of these principles, we are not just doing the talk, but we are actually able to walk the talk with these set of guidelines and put that into practice with a lot of toolkits. So with practices, we have these 5 broader guidelines that we have outlined, which is the human AI guidelines, conversation AI guidelines, inclusive design guidelines, AI fairness checklist, and data sheet for data sets. With that, actually, let me show you where you can find it and maybe go through each one of them. So this is the tab where you can find all of our responsible AI resources, and you can see the human AI interaction guidelines. Basically, these are the guidelines. These are the guidelines that you can use for designing AI systems across the user interaction and solution lifecycle. So let me show you what kind of things it would typically help you with, right? So here I have a demo with me, and this is a openly accessible demo. You can go and look at it yourself as well. So basically, I have guidelines for human AI interaction here, and I can maybe throw in this card from this set of decks and see the kind of examples and the principles it's laying out for me. So here it talks about what would be the phases of the interaction with human of the AI system. It talks about the initial interaction. It talks about during interaction. It talks about how the AI system must respond when the AI system is interacting with the human. So while we have the limitation of time, so I won't go deeper into each, but maybe let me throw in a couple for you to get an idea of what these things really look like. So if I look at it here, the first one talks about the initial phase, where it talks about how an AI system must make it clear about what the system can do, right? So helping the user understand what the AI system is capable of doing. So here you can see a couple of examples in practice that are thrown up, and Apple Watch being one of them, where it talks about displaying all of the metrics it tracks, and it explains how that metric will be tracked, right? So we have that here in the initial phase. Now let me maybe throw in this around during interaction. So if I talk about during interaction, it talks about mitigating social biases, right? So ensuring that the AI system's language and behaviors are not reinforcing any undesirable and unfair stereotypes and biases. We talked about it a little earlier, but this is how we're really also putting that into the guidelines for human AI interaction. Now, if you see here, we have an example of how my analytics is summarizing how we spend our time at work. And one way it mitigates bias in that context is to make sure that it's using gender neutral icons to represent important people. So that's one of the examples that it has thrown at us. And there are a bunch of others that it's talking about, as in a Bing search for CEO doctor shows images of diverse people in terms of gender and ethnicity, right? So these are some of the things that you must keep in mind when you are designing your own AI system, of how you can mitigate social biases when during the interaction process. Now the third section is around when wrong, right? So how does the AI system respond when wrong? So how does the AI system respond when wrong, and what are some of the ways that you can interact with your user in this context? So it talks about in here about scoping services when in doubt. So engage in disambiguation or gracefully degrade the AI system's services when uncertain about a user's goal. So if you see here, there are some examples that are listed, which is about Siri, on how Siri will let you know if it has trouble hearing if you don't respond or speak to softly. So these are some of the examples that are listed. So if you see here, there are some examples that are listed, which is about Siri, on how Siri will let you know if it has trouble hearing if you don't respond or speak to softly. So these are some of the examples that are listed. So if you see here, there are some examples that are listed, which is about Siri, on how Siri will let you know if it has trouble softly, right? So Siri or a Google Assistant or Cortana, any of these, if you engage with on a daily basis, might have seen it yourself, where they come back to you and say that, okay, I'm having trouble hearing you, or sorry, I don't understand. So in that sense, it's really clear to really scope those services when in doubt. And this last section is about notifying, over time, how does it really engage. So here, one of the things that are thrown at you, let me take this one, which is about notifying the users about changes. Basically, informing the users when the AI system adds or updates its capabilities, right? You can see here an example is thrown at you for the What's New dialog in Office, which informs you about changes by giving an overview of latest features and updates, and including updates to AI features. So this is something that can be used to notify users about change, and over time, these are some of the guidelines that can be helpful in the human AI interactions as you look to plan it through your AI systems. So that's the number one thing that we have here in our set of responsible AI resources, which is on the human AI interaction guidelines.
Excuse me, Priyansha.
We also have the conversation AI
Priyansha,
guidelines,
sorry to interrupt you.
which is again an interesting piece because
Can you hear me?
this is really around all of the chatbot conversations and how really can you design it in a way to make sure that it's a trustworthy bot, you're ensuring reliability, and you have consequential outcomes. It's fair and diverse, and you're respecting privacy. So maybe I'll show you an
I guess there is some issue at Priyansha's end. We apologize for this delay, and we'll just be back in a few seconds. Sorry, for that, Microsoft will be providing the top 5 scorers of the quiz with the role-based vouchers for examinations of 70, 74, and MBX series valid only in India. Please keep that in mind. And it is not for the AZ900 certifications.
All right. Am I back on? Okay, I think I am. All right, so apologies, folks, for that technical glitch. Let's get back to where we were. I think I was talking about the conversational AI guidelines. So, like I said, there are a bunch of guidelines that we have here. I hope you do not lose me through this. So, basically, what I was trying to take you through was, how you can build some of these things into your chatbots and make sure that you are building a responsible conversational AI system. And in this context, we're talking about building a trustworthy bot, right? So here you can see that it's talking about providing a feedback mechanism, and with that, the bot really ends that conversation with how you can improve my performance. Is there any feedback that you have to share with me? And this feedback is what would really make that into a full circle and help that bot get better with time. Now, I again, I have a lot to cover, so in the interest of time, I won't go into each and every one of these, but let me cover just one more section for you to get a better understanding of some of the guidelines that we have outlined for conversational AI. So the next one that you see around here is a pizza bot. So you'll see a pizza bot here that that starts the conversation by putting the context of the ordering, order now, or get help as the two options that the user can really start with. So for a bot to be useful, it must actually work, right? And humans are quick to discount these experiences that don't work, and our negativity bias will ensure that if a new experience is bad for us, we will not only avoid it in the future, we'll tell all our friends to avoid it as well. So in that sense, we must make sure that whatever is the bot's primary purpose, that the bot should be able to do very reliably, right? So in this case, what we're trying to do is we're starting the conversation with the primary context that the bot has, and here the user is asking for get help, and it really goes back to clearly define that, okay, these are the other things that I can do, these are the tasks that I can do, and to ensure that the users can discover and choose from it, or select if they want something else, right? So in this case, the user has selected something else. So since the bot cannot handle this has been handed off to a human operator. So this is also very critical to make sure that the user does not have a bad experience with the chatbot, right? So some things a bot just won't be able to handle. So in this case, it's very important that when necessary, a human operator is able to get involved and help our users with what they need. So with that, you can see that an operator has joined in, and the conversation is being carried forward with the operator. So it's talking about the order they made earlier, and where is the order right now, and okay, and all right. So the operator has taken in, and after that, the bot has come back in to provide feedback, to get feedback and close off the conversation. So that's one of the ways to make sure that your bot is reliable. You have ways to hand off to your human, and you clearly define what your bot can and cannot do. So with that, let me move on actually to the next section. While these are things that you can explore in depth on your own. So human AI guidelines I briefly covered, conversation AI guidelines I briefly covered. There is also the inclusive design guidelines and the AI fairness checklist to make sure that your systems are inclusive by design. Your systems are treating everybody fairly. And I think this one's my favorite, which is the data sheets for data sets. So this is actually a very interesting thing to make sure that how in electronics every IC or every electronic component comes with a data sheet, right, which explains what the IC can do, cannot do, what are the configurations, what are the pin numbers, what is the exact electronic details of it, etc. So with the same analogy, we have tried to create data sheets for data sets that can clearly define what the data set comprises of, how it can be used, where the data has been sourced for. All of that can come with the data set to make sure that the data scientists can use the data sheets as something that aids the whole process of understanding the data set. With that, let me also now move on to the next section, which is around tools. So when we talk about tools, there are three key pillars that we primarily discuss. The first one is around understanding. The second one is around protecting, and the third one is around controlling. So understand, protect, control form the three pillars of our tooling technology that we're building. I will go deeper into this in just a minute, but before that, I also want to briefly touch upon the governance part of it, where Microsoft has put together this framework for governance to make sure that again, everything from principles, practices, tools to governance, to make sure that it's a full circle and everything is put into action. So we don't want it to be just a conversation, but it should be something that is by design built into our systems, and by design we're helping other developers and data scientists also build it into their AI systems. So with that, we have an Office of Responsible AI internally, we have the Ether community, we have the Responsible AI champs to really support the governance measures as well. All right, so let's go deeper into tooling innovation. So this will be the last section that I'll cover today, which will be on the tooling bit and what all do we have on that front. So I think if you look at the tooling bit here, like I said, it is on the three pillars that we talk about, right? So the understand, protect, and control, and all of it in collaboration with Microsoft Research and its working groups. We are bringing the latest research in responsible AI to Azure Machine Learning. So the next few minutes, I will talk about how the new responsible ML capabilities in Azure ML and our open source toolkits can empower data scientists and developers to understand ML models, protect people and their data, and control the end-to-end ML process. So let's look at each of these three pillars in detail. So let's start off with understand. Now, when we look at the understand pillar, what we mean here is it comprises of driving an understanding of the model's fairness index and its interpretability. But what does that really mean? So one challenge with building AI systems today is the inability to assess and mitigate unfairness in the models. Now, to address this challenge, we have recently open sourced a toolkit called FairLearn. Right, so I will quickly maybe show you a quick demo of the same as well. But there are primarily two components to FairLearn that we talk about. One is focused on the fairness assessment, which is basically a dashboard with both high level and detailed view for assessing which groups are negatively impacted. And second is on focus on the mitigation, which is basically how a set of algorithms can help you mitigate the observed fairness issues. So here you can see the fairness input selections yielding into assessment results, and the fairness criteria really helping you do the mitigated model and do the fairness mitigation bit, right? So these are the two primary components of FairLearn. Now these strategies are based on a variety of supported fairness definitions, such as demographic parity or equalized odds for classification tasks. Now supported unfairness mitigation techniques can easily be incorporated into existing machine learning pipelines and assess model fairness during both the model training as well as deployment phase. So together, these two components enable data scientists and business leaders to navigate any trade-offs between fairness and performance. And I think I saw a question on this earlier in the chat window, but what we're really trying to do is really leave it up to the business leaders to make sure that they understand the trade-offs that may come between building fairness into their systems and making sure that they're still performing up to the standards that the business leaders expected to perform to. So with that, they can really pick the best mitigation strategy that fits their needs and use FairLearn to really leverage those specialized algorithms to ensure fairer outcomes and use the built-in visualizations to understand the same better. So with that, let me actually show you one of the dashboards that I have here. So you can see here, this is one of the dashboards now. This is basically in context of a project that is being done for credit card applications. So we have some data around credit card defaulters, and we're trying to predict, who's more likely to default versus who would not default a credit card payment. So you can see here that a sensitive feature has been picked. Maybe I'll show you what the dashboard initially runs you through. So the Fairlearn dashboard initially, to set up the assessment, needs two basic things from you. One is the sensitive features, and the second is the performance metric. Now, if you look at the sensitive features, basically these sensitive features are used to split the data into groups, and fairness of your model across these groups is measured by these disparity metrics. So these disparity metrics quantify how much your model's behavior varies across these groups. And performance metrics is on how you would use it to evaluate the overall quality of your model, as well as the quality of your model in each group. So basically, the difference between the extreme values of the performance metric across the group is also reported as a disparity in performance. So with that, let me go ahead and pick out the sensitive features. In this case, I am picking gender as a sensitive features, and the subgroups defined are 1 or 2. We can assume that 1 is male, 2 is female. And with this, I can also pick a performance metric. So I have a performance metric that I can pick across accuracy, balanced accuracy, precision, or recall. So for this case, let me just go ahead with accuracy and see what it shows me. I think it's I'm having some trouble connecting, but primarily what Fairlearn really comes back to you with is on a dashboard that can help you understand how the fairness is looking like right now, how your model is really treating different sensitive groups right now. So basically it will show you an assessment result that will show you the over prediction and under prediction for two select set of groups. And in the fairness mitigation phase, you can use some of the algorithms like a threshold optimization optimizer that I had in my demo to mitigate this fairness and see how the results are changing over that. And then also see how the trade-offs are looking like with building in this fairness into the system, and also making sure that they're performing well. So that's pretty much on Fairlearn. Maybe at the end of the session, if that model loads, I can also show you what that dashboard looks like. But in the meantime, maybe let me move ahead and cover the other segments of the tooling practices that we're talking about. So the next section is around understanding them in understanding model. The next section is around interpreting the model. So another important aspect of understanding a model is the ability to explain it or explain its results. So this is where interpret ML comes in. So as its name suggests, it helps interpret models and their results. So it's basically another toolkit that we've open sourced, and it can be used for both glass box and black box models. So you'll see glass box models are designed to be interpretable. They provide lossless explainability as they use interpretable algorithms, like you can see decision trees here, and they are interpretable algorithms, and they can provide lossless explainability. On the other hand, interpret ML can also help with black box model to a certain extent. So black box models are based on more complex techniques like neural networks and can be a little tricky to interpret, but you can still achieve approximate explainability with black box models, like with using explainers like Lime or Sharp. And interpret ML uses these explainers to surface a dashboard with feature importance. So with this, interpretability is needed to you can use both of these in combination to make sure that you have a very good understanding of your model, and you're able to make sure it's fair as well as interpretable and explainable on both ends. So that's pretty much on the first pillar around understanding your AI systems. Now the second one is around protecting. I think again I saw a question in the chat window around differential privacy. This is pretty much what I will be covering in this section. So if you look at the differential privacy toolkit here, so basically when we talk about this particular scenario, let's maybe envision a scenario where a data scientist wants to use some sensitive data to create a model, right? So in a non-protective protected scenario, this would result in submitting a query to a private sensitive data set, and providing the right credentials, they'd receive a sensitive data as a response to their query. Now, this can be very problematic. The data scientist can look at sensitive data and potentially even deduce PII about an individual. So this is clearly not at all compliant or ethical. So let's introduce our differential privacy toolkit within the OpenDP initiative that has been developed by Microsoft in collaboration with Harvard's Institute of Quality Social Sciences, which basically makes sure that there is differential privacy by first. So what this is really doing is white noise will ensure differential privacy by first, and it will manage exposure risk by tracking the information budget used by individual queries and limiting further queries as appropriate. So in our example, you can see that the query is first validated against the information privacy budget and processes only if it is an overrun. So you can see here that submitting a query and the process query only if privacy budget allows. And on the other hand, white noise is also injecting statistical noise in data without significant accuracy loss to basically help prevent disclosure of private information. Again, in our example, because the query response may be sensitive, before it reaches the user, it is injected with white noise to make it differentially private. So in addition to differential privacy, you can also protect your data on Azure ML using hardware-backed confidential ML capabilities and homomorphic encryption, and ensure your data isn't compromised at any stage of the ML cycle. So that's on differential privacy, which forms the key to our second pillar, which is around protecting. The third one is around controlling. Now, if you look at it on the control side, there are some features and capabilities that allow you to manage your audit trail and data sheets for the models. Within Azure ML, all the actions undertaken throughout the lifecycle of an ML model can be tracked for auditing purposes. Now, this audit trail enables us to trace the lineage of the training data, the operations performed on it, its drift, and most importantly, the model versions and the various deployment endpoints. Now, this is important for compliance reasons, and organizations can leverage this audit trail to trace how and why a model's predictions showed a certain behavior. So additionally, once you have a model, it's important to capture its properties and purpose alongside any other metadata that could be helpful from a reusability standpoint. So in Azure ML, we enable this with custom tags you can define for model and capture all this information so that it travels with the model. Audit trails and data sheets can enable the accountability for models and are an integral part of the responsible ML scenario. Now you can see that accountability, fairness, all of the principles that we talked about earlier are all coming to life with the practices, with the toolkits that we're defining, right? So we talk about accountability in this one, we talk about the fairness in the other one. So that's pretty much all coming to life with the toolkit, with the practices coming into picture. So with that, I think that was the last one that I wanted to cover. But before we close off the session, I would perhaps encourage you to go on to our Responsible AI resource page to explore all of these for your on your own and see what makes sense to you, to make sure that you're able to build responsible AI technologies, and you're able to leverage all of the practices, tools to make all the principles come to life. So I think with that, I'll maybe close off the session. But you can always connect with me over LinkedIn, and if you have any other questions, we can connect offline and take it up. Thanks a lot for joining today, and my apologies for the technical glitch. And I hope the session was useful for you. Thanks a lot.
That was a great session, Priyansha, over the responsible AI. So we have 4 questions for you in the chat section, comment section. So Abhinav Prakash wants to ask, would you please tell us how federate learning will be a game changer in AI privacy? Priyansha, can you hear me? I guess there's some issue on Priyansha's side. Okay, without wasting much time, let's just move forward to our next session. We shall be getting back to Priyansha once she's there. So for the next session on leveraging AutoML to fit your needs, I would like to welcome Akanksha Malik. Over to you, Akanksha.
Okay, can people hear me? Can just someone say yes or no, just so I can... I'm going to pretend that people can hear me because no one's going to say anything against it. Okay, cool. My name is Akanksha, and I'm here to talk about AutoML and how you can make the most of it to fit your life. And those are my details. Let me just make that into full screen. Don't know why it didn't work straight away. Okay. Right, hang on now. This is more problems that are happening. Did that on, okay, I'll leave it on that mode. I think it's taking the screen share off. Anyway, we're here to talk about leveraging automated ML and how it can fit your needs. As you can see, my name is Akanksha, and the best place to find me is probably Twitter. So if you do have any questions after the session or you need any of the things I have up, reach out to me, more than happy to help. And with that, let's dive really, really deep into machine learning and talk about me. It's a great way for everyone to get on the same page, and it kind of slows me into talking. And so, yeah, that's me on the right-hand side. Not the ginger hair one, that's not me. But that I am from Ireland. I did grow up in India for a little bit, but I mostly was actually at school and college in Ireland, and I studied financial maths and actuarial science. And what I realized while studying financial maths and actuarial science, this big whole mouthful of a degree, was I did not like doing actuarial science, but I did like my data stuff and the theory and the probability parts of things. And that's kind of how I ended up joining into a grad program here in Melbourne, which was all about data science. And I started, and here I am as a data scientist 2 years later, talking about all these things in machine learning that I find really, really interesting. And I was like, someone else might find it interesting and might be helpful for them too. So that's what I'm here to talk about. Just a disclaimer, because I am Irish and the accent can get a little bit thick, or I can speak really fast at times. If that is happening, I've got the chat open on the side. Let me know. I will try and keep an eye on it. If I'm going too fast or you need me to slow down, it's easier for people to understand me than to not. Let's not waste anyone's time. Okay, with that, let's actually go into this a little bit more and talk about why we're here. If my slides want to move. So today's agenda is essentially we want to create a model with no code at all. So that's going to be using the automated ML, and also at the same time see how Azure Machine Learning Studio, the whole platform, is enabling different skill levels and how you can leverage you can use absolute no code, or how you can just use different parts of it to make your own models better. So that's our agenda. And hopefully at the end of this, I want to see at least one person, please make me happy and actually do this, at least one person go away and try to make their own model with this. And please let me know if you do, because that makes me really happy and makes me feel really, really cool that I've helped someone do something. So please do that. Let's talk about AI in the market, right? It's this big buzzword. Everybody wants to know. Everybody wants AI. And it's this thing of like, yep, it's guess a good and a bad thing. People think about AI in terms of, oh my God, this is going to change people's lives. This will make things so much easier. It'll reduce the need for so much cost and things. It's a really cool place to be in. Some of the things it's doing is amazing. And the other end is, oh my God, it's taking our jobs. And what is happening? Nobody wants this. It's just listening to everything we're saying. And there is a midway between it. I think Priyansha's presentation just before me about responsible AI is very important. So please keep those kind of things in mind as you do go create all your AI models in the future. But it's important and it's really big in the market, but there are some challenges with adoption, right? Everyone wants it. If you talk to anybody in any company, they're like, oh my God, bring me AI. It'll save me X amount of dollars or X amount of euros. It's amazing. But there can be so many different challenges with actually implementing it. So what you'll find with businesses is they'll start, they're like, yep, we're going to do AI. And then that'll be the end of that conversation because they might not have the people to actually do it. Don't get me wrong. The demand for jobs and the amount of people who are data scientists and data engineers and so many different under the job descriptions under the data bracket. But there's a talent gap still, even within the amount of people we seem to see. And there's language barriers. And I don't mean that in the language of English or whatever else it might be. I mean that in terms of the coding language. I mean, even just very simply, if you look at it, we've got Python or R. That's a very big divide immediately. And if your whole business is built on Python, you can't really hire someone who's only had R experience because they won't, I mean, they can learn very quickly, don't get me wrong, but it'll take time to get used to it. And then processes. Setting up environments. I don't know if people have tried this yet, but I've been on client projects where it's taken me about 3 weeks, up to 3 weeks to get access to things, to get set up on the thing and have it all ready to go. And that's just time wasted. And that's a cost to a business in terms of getting things ready. And then managing all those infrastructure and the integration of different things, having servers in your building, whatever it might be, managing those is another cost. And it can just be kind of unflexible in terms of how do we make it bigger or smaller. And that comes to our technology itself, where security is a very big concern at this day and age. There's so much data, which is great, but there is so much data. How do we protect it? So it's kind of a double-edged sword for almost every possible amazing thing that you can think of, or anything to do with AI, really. And yeah, so as I mentioned already, the lack of flexibility, it comes with everything within technology. If you've already built your product out onto something, how do you change it? If you've already built it on X platform, how do you go to Y, if that's all you have? So with that, there's this new kind of movement that's coming in, and this is like my favorite topic to talk about. It's called democratizing AI. And what this essentially is, everybody has data about them existing in the world. Everybody should be able to leverage that data that they have for themselves. It shouldn't be a skill necessarily that's only kept behind bars of you have to have done a degree in computer science or maths and then have to do a PhD in like really technical things. Only then can you really make the most of the data that you have. It shouldn't be that case. It should be for every single person and everyone should be able to use it. So that's kind of why I enjoy talking about this. And that is why I'm here to talk about how you can leverage it to make the most of it for yourself. So just taking a little technical step forward, we've got Azure Machine Learning Studio. And there's a few different brackets. Sorry, if this was in full mode, these were really cool animations and slidey things that could happen. But there's a few different parts to it. So you can be someone who has full coding technical abilities or absolutely no coding abilities. When I started my job, I had minimal to no coding abilities. And because I did a degree in maths, I wrote math solutions down on paper. I didn't even write those out onto anything else. But I learned as I went, and that was great. So it could be someone who has nothing all the way to who is a complete programmer and knows exactly what they want, use the command line for everything. I don't think I will ever be a command line person, straying from the point. And on the other hand of it, anything to do with AI or machine learning, you can have someone who's a machine learning expert who knows every single, they know exactly what libraries they want, they know what hypertuning is, they know exactly what parameters to tune where, and they can just look at a model and they're like, yep, if I do this, this will happen. Those are experts. But then there's also people who have no idea what machine learning is, like my parents, for example. Like they have data that they want to see, like, hey, Akanksha, you do some AI stuff, make this smart. Like I get that question so many times. Like just go make it smart. They don't necessarily understand anything about machine learning, but they know that it can be smart, that what they have in front of them can be leveraged. And within that, Azure Machine Learning Studio has 3 main products, and you might have heard of them before, so bear with me if you have. But for those who haven't, so the main first one is notebooks and the SDK, and that's essentially for those people who know exactly how to code and they know what their machine learning is and what they want with it. So they go in, they bring out all the libraries that they want, they pull out whatever they need, do their data transformations, and off they go with their tuning and the actual learning parts of it. And that works really, really well on a platform like Azure Machine Learning Studio because it provides a really cool workspace for you to collaborate with your team members and also just really cheap compute. You don't need to have a $7,000 MacBook Pro sitting in front of you, really teched up to be able to do any of these machine learning models. You can just do it on the cloud fairly cheaply and it's good to go. And you can scale it up or down. If you If you've got a boss who's like, no, I want my machine learning model tomorrow, scale up your compute, you can have it done, no problem. AutoML on the other end of it is the complete opposite, where there's absolutely no coding needed. You don't need to have any background in it, and you don't need a machine learning background either. You just basically give it your data and you tell it what kind of prediction you want, and it does it for you. And it tells you what the best model is, and it'll basically tell you how to deploy it, and off you go. It isn't very time consuming, and it's fairly quick depending on how big your data is. I think I gave it like 100,000 rows just to learn from something. It took like 40 minutes. It's very quick, and it just cuts down. I mean, this is not just for someone who doesn't understand machine learning. This is also for your machine learning experts who just need to take the time, who don't want to spend their time just trying different things here and there. I mean, for me, if I could use automated ML to tell me, okay, these are the top 3 models, go make those better, that's great. I get to take a lunch break, an extra hour. Makes my life a little bit easier. And Designer kind of sits in the middle of the two, and we won't really be looking too much into it, but essentially what that is a drag and drop platform. So you don't need any coding abilities because you can just drag and drop exactly what you want to do with your data, but you do need a bit more machine learning understanding in terms of how do you set up a machine learning pipeline. So you need to have your data, you need to clean it, what kind of things should you be cleaning and what you shouldn't be cleaning. You need to split it into training and testing and what exact algorithm you want to actually train it on. So those kind of things you do need to know, but the coding part isn't there. So for someone like me who did statistics and a bit of machine learning, who kind of knew it, it's a great place for me to come in and be like, oh, this is how it works. I didn't have to worry about the coding part, but really get my own head around machine learning and then go back into doing the coding stuff. So it kind of has something for everyone in this. And with that, I won't spend too much time here. I'll actually jump straight into a demo now. And this is the talking part at you done. So this is just to give you a quick idea. And now let's go into our favorite place, which is our portal. This is what you always want to be seeing on Microsoft. And from here, you can basically look up machine learning and create a new workspace. And it's a fairly painless process to actually setting up your workspaces. Pick a resource group. If you don't already have a resource group created, you can create a new one right here. It takes 2 seconds to type out a name. Just give it a name and where you want it to sit. And the other things, it can essentially do it for you. So if I name this test int, okay, that'll do. It's already created all the storage accounts, the keyboards that go along with it, all for you immediately. All you need to create is just a name and a resource group. And that's it. And you click create, and that's good to go. So I've got a couple of, I've got a couple of these already open, so I'll jump in. And once you open your studio, this is what it looks like. And it's a very clean kind of workspace looking thing, and I absolutely adore it. So as I mentioned already, there's the notebooks, your automated machine learning, and your designer. So what we're going to start with is automated machine learning. And we want to create a new run. So I basically just want to really quickly show you how easy it is to set up an automated ML. For an actual data set, where do you want to find your data? You can find it from your local files, a data store that you've already got in Azure somewhere, whether it's open data sets or somewhere online. If you have a Kaggle data store, you can actually link it directly from that, or the open data sets. This is a really cool feature if you haven't heard about it yet from Microsoft, where they've got all these data sets already existing here, and they're free to use, so that you can kind of use these just so you know exactly what to do with it and practice, basically. So let's just look for taxis. Huge data set. Really, really handy to explain. Everyone knows what a New York taxi looks like. It's those big yellow ones. And if you're going to America, you kind of also know about tipping systems. Obviously, I don't think anyone's going to America at the moment, but when we get to a post-COVID world, we might be going back. And it's a great handy little thing for someone who isn't from America to know how to tip your taxi driver. I have no idea. Maybe my machine learning model will tell me. And you give it a name. New York taxi, that'll do. And I'll pick maybe the last couple of days, just for a quick demo. I think I picked a month. Oh, let's pick that. And this is where I pray to all the demo gods that this doesn't fail on me. I can create a new experiment, if I've already got experiments going and I want to keep everything bundled into one place when I'm doing different things, I can select an existing one. I don't have it, let's create a new one. Let's call it testing AutoML. And what's my target column? So like I said, I want to be able to know how much I should be tipping. So I'd like to predict my tip amount. And we need a compute cluster. And as you can see, nothing's popping up. That's because I haven't created a compute cluster. So when you think about any kind of artificial intelligence or machine learning, there's two main important parts of it. One is going to be your data, and one's going to be your compute. And for example, like here, I forgot to show you how to create compute at the start. That's not a problem because Azure Machine Learning has basically preempted that. In case you do forget, it's not a problem. It'll actually just tell you how to do it directly from here. So you can select a virtual machine, you can pick a region, if it's dedicated or low priority. If you need your machine to be only for you and you need it to be done within a specific time, keep it dedicated. Low priority will cost less, but also might drop your job and might take longer. And it's already picked one for me, which it knows will be the best. And it's kind of your standard DS3 version 2 one. I'm okay with that. And literally all I have to do is click next, give it a name, pick how many nodes and clusters I want. Always, pro tip, always keep your minimum number of nodes to 0 because it's auto scaling. If it's not being used at any given time, it'll scale back down to 0 and it won't charge you. I've had this happen so many times where I've left things running overnight and been charged a lot of money for them. Just keep that in mind, or maybe just always shut it down. And so you can scale this up. So as I said, talked about flexibility earlier on and scalability. If you have a model that needs to be done in the next 20 minutes, scale the whole way up and maybe get a bigger machine and use that. It might cost you a little bit more, but that's not a problem in the bigger sense of instead of costing you $1, it might cost you $5 kind of thing based on how much data you have. Those are very guesstimated numbers off the top of my head, so please don't take my word for it. And that's it. And you hit click create and that'll create a compute for you. I'm just going to cancel it because I don't really want one right now. I take that back. I probably should have one because I can't move on to the next step. And I've already clicked out of it, of course, but it only takes a second. And while that's creating, let's talk about data sets. So because this is obviously in Azure, the great handy little part of this is the fact that you can connect this to any data store or any data kind of thing you have stored within Azure, whether that's a data lake, blob store, new Azure Synapse, wherever it is, because you created a key vault while you were setting up your workspace, you're actually able to quickly see where everything is and auto connect to those through your key vaults and have no problem at all. I'm so sorry, I feel like I should have created this beforehand and I'm regretting not doing that. That's your data. In terms of compute, there's a few different types of compute that you can have when you're talking about machine learning. So one of the main ones are the one we're looking at right now, which is a compute cluster. And what that essentially is a couple of machines that group together to make your work power, basically. You are doing machine learning, so you need a machine to be able to do it. And you can have as many machines or as little machines as you want. So that took about a minute or two to create. Once that's done, I click next and it's got rid of my testing one for some reason. And this is the last step in an automated ML run, which is a case of actually telling it what kind of machine learning you want. So there's 3 main types that it currently caters to. It's got classification, which is you kind of go to what kind of a thing is it? Is it a yes or a no kind of a question? Or if it's grouping things into what color is it? Like it says blue, red, or green. That's the kind of problem you want to do classification with. But what I want to do is predict a specific tip amount. I don't want to say, is it tipping or not tipping? I want a specific, this needs to be a $4 tip if you're taking a $25 taxi. I want some numbers like that. So I'll pick regression. You can also do time series forecasting with this, which is super handy because of the fact that all you have to do to tell it is this is my date time column and it does everything for you. It's very cool. And you can pick features and additional configuration settings, but I choose not to. if you don't want to. If I hit finish, this will start running and learning on this data that I've provided. And if I look at the time, that took me literally 5 minutes from setting up a workspace, connecting to my data, setting up my computing power, and actually hitting go, like to getting it all done. And this required no coding abilities. The data was ready to go for me. And this is that case of, if you are someone with no machine learning understanding, all you really need to understand for your data is what kind of a task you want your machine learning to do. Is it a grouping or is it a prediction? That's basically it. And you're done and it's ready to go. And what that looks like, I'm just going to X out of this for now. This is a pre-ran one that I have run in the past before. So this is the same data set run. And you can see it's got a few other metrics here you can check out. Bunch of numbers here, but I think the interesting one was just when RMSE was 0.0061, which I'm like, whew, fabulous job that it is doing, I'm not gonna lie. But it is doing 100% sampling. So don't get me wrong, it's a very quick look into doing this. It can be really, really cool, but it's something definitely to be taken with a grain of salt. You should go do more things after it. But for someone who's just looking for a very kind of quick look at something, it's a great place to be. What can you do with this now that you've run this? There's a load of different things. So that's the best model it tells us, and it'll give you more details around it. And what you can do is actually deploy this. And what you need to be able to deploy any of these models is a Kubernetes service, which again, if you don't already have it set up, maybe I do have it set up. If you don't have one, it'll actually lead you to creating a new one, as I showed you earlier. But this is, again, essentially a cluster of different things in an AKS service. Please don't ask me anything about Kubernetes. It's a very big buzzword that I don't actually have an answer to. I haven't really messed around with much with it, but I have deployed things into a AKS. It works fabulously. I won't do that for now, but what that essentially, once you click go, once you deploy a model, what it gives you back is a REST API. Off you go, connect that up into your app. You've got a model essentially in 5 minutes of work, about half an hour of training, and within about an hour, you can have it connected up into your app and put some smarts behind your app if you were creating an app that was predicting tip amounts for taxis in New York. That could be something you actually wanted to do. And another cool feature within this is explanations. It's still under preview at the moment, but this, I think, is just really, really cool in terms of actually telling you why your model is doing what it's doing. So we're asking it to predict, I think it was the tip amount in this one as well. If it ever wants to load, I have a feeling people have come home and started using the Wi-Fi. But what it's telling us is to predict I'm pretty sure it's a tip amount. To predict tip amount, the biggest feature out of my whole data set was the fare amount, which, I mean, kind of makes sense, right? You need to know how much you've actually paid. And so whatever your fare is, your tipping amount is a percentage of that. So that makes sense. And the amount of tolls, and apparently that's a really big feature as well as the distance traveled. So if you're traveling for a longer time, you're obviously going to be paying more, therefore you'll be paying a higher tip. These things make sense. And it's great to be able to see the fact that, like, yep, my model actually makes sense in that sense. Like, what it's using as features are, yeah, I'm like, I understand that. Therefore, the model understands things accurately. If it's doing something really, really weird, that it's using a weird feature as the highest important feature, you might want to have a look at that again and just be like, maybe I should go back through this a little bit and just test it out. So that's still in preview, and they're making loads of different changes on this. So something to look forward to. But a great way of actually showing, say, someone who doesn't understand it. It's like, this is what your model is doing behind that black box that we seem to think of as machine learning magic. But that's automated ML kind of on its own from a no-code preview, which is great. But like I said, what if that model that it created wasn't the best, or it just kind of gave you a hint of, okay, maybe this is the kind of specific model I should use, or better still, you have data, but you need to clean your data and you need to do a lot of transformations to get it ready to be able to get to a stage where you can run machine learning. And you can only really do that, say, in Python or R, no problem, because we can jump into notebooks, and I'll go through and show you exactly how you can use automated ML within a notebook environment. So these are your notebooks, and I've essentially created one here. Sorry, my subscription was messing up earlier, so I couldn't create a compute to actually show you this live. but this is, it has been run. I think I ran this like 2 days ago or something. So that you'll see exactly what this data will, these code snippets will do, but it won't be live. I'm so sorry. Okay, so we download and prepare our data. As I mentioned, it's the New York Taxi data set. I've downloaded a specific time, so I think if I can read correctly, it's the first month of 2015. So January 2015 is what I downloaded. And there's a few different, because it's such a big data set, the New York Taxi data sets, you can only download into the, I can't think of the word, but into the notebooks, you can only download 1 month at a time. You can do more and actually compile them together, but I stuck to just the 1 month for now. Off it goes, does all that, and actually shows you exactly what it's downloaded, which is great to see. And once I've done that, I want a baby, like, that's great. It's got a few columns. It's got 23 columns. It's saying I can have a quick look at them if I'd like. Pick up date time, drop off date time. I mean, that's great, but it doesn't really help me in terms of when I'm planning a trip, right? Because I know for a fact that if it's a weekday, it'll be way busier, maybe less busier than a weekend, but it's definitely going to be a different timing. What does peak hour and non-peak hour looks like? So what we can do is actually split them out. So this is kind of those things of we can import a feature called building time features, split my data set into things like days of month, day of week, hour of the day, so that I can later on group them into different things. So that's what that data transformation is there. And then I look at my data set and there's things in there that I'm like, no, I know for a fact it's not going to be helpful. And how do you know for a fact? You could maybe have run an automated machine learning run like we did. Look at the explanations tab and see the different features. And in the features, you can tell that they like all these different columns, like the trip type, the rate code, all these kind of things didn't actually have an impact at all on what you were doing with your model. So you can remove those columns. Once that's been removed, you can have a quick look again. So it's looking a little bit tidier now. We've got hours, day of the month, what month it is, what the total amount was, and drop-offs and actual latitude and longitudes. And once you've done that, we can actually start cleaning the data, because obviously we get it into the shape we want, we transform it, and then we have to clean it. What if there's faulty data or there's just numbers that don't make sense in there? We should have a quick look and start removing things that kind of don't make sense. So if you've got a problem, there's always going to be a few outliers, even if it's true data, but it's just so far out of what it should be that it's going to impact your model too far to really have an accurate response. So you kind of get rid of that in those sense. A lot of statistics goes behind it. Again, this goes back to responsible AI. Make sure you're being a little bit responsible and not creating bias into your data by doing certain things. So just be careful when you do things like this. But there was just a few things that I think moved around. Essentially things like, well, if I'm going to New York, I'm only really going to be on, say, Manhattan. So we can limit exactly what our latitude and longitudes are, the trip distance. I mean, is anyone really taking a trip? Well, I definitely wouldn't be taking a trip less than, say, half a kilometer. Even then, I'd probably walk that, but just to get rid of some like really small outliers. And then really long ones. I mean, 31 kilometers, I mean, that's kind of as far as you'd probably be going. So I'm like, yep, let's put it into the middle of those two. And this is another case of you might have faulty data. What taxi trip is costing money if there's 0 passengers? That doesn't make sense. So you want to have it obviously over 0, and you want to have the total amount also being over 0 because you actually want a fare to have happened. And once I've done that, off we go. We can put that in. Our data set now looks a lot different than what we started. Sorry, I'm trying to scroll this down so that you can see while also, okay, that's weird. I can't seem to scroll sideways. Maybe I can. Oh, I can. Okay, sorry, I just have to use a different mouse for that. But not many more columns. And this is kind of where your own intuition about how does machine learning work come in a little bit more. You kind of know, oh, these things aren't really necessary. I really need to be like a little bit more focused on what my features are and what I actually really need to use. That comes with practice. And there's a lot of open data sets available on Azure. Go try it out, go enjoy them, see what you get with it. Once you've done that, we need to make a workspace that our notebook can connect to for our automated ML. And as always, with machine learning models, we split it into training and testing sets. It's literally like being back in school. You're trained, taught on certain things. And then at the end of the year, there's a test on it to see how well you've learned it. Same thing goes for machine learning model. We're teaching a machine how to do stuff, and then we're going to test exactly how well did it learn over the time we gave it. So once we've done that, off we go. We've done that split. What did I split this into? 80% is what I said. So I wanted 20% of the data set aside that it's never seen it before, and I want to actually test that afterwards to see how well it does. And once I've done that, so this is a case of now, if you are someone who likes to code and know how to code, you can do all of this in just Python or whatever other language you want to use. You write this all out. Now, at this stage, once you've gotten it ready to train, you use, instead of picking a specific algorithm, you get AutoML to go run on your model and find maybe the top. You can pick however many you want to see, but it'll definitely give you at least a top model that it finds. And then once you've gotten that, you can do whatever you want with it. So let's talk about this. To define certain things. So as we talked about, as I showed you earlier on in automated ML, it was like 5 clicks, this, and this, off you go. Here, obviously, you need to define a lot more things because there isn't really clicks and you're really going to have to fully tell it, just like any other coding environment. Automated settings, these are all available, really well explained and documented on the Azure docs. So the config class is there. Have a read through when you actually start coding about these things. Every single parameter is explained. So things like primary metric, which will be your most important one, actually individually go through all the different metrics and stuff. Sorry, that's classification and regression. There's a few other things in there that you can go through and figure out exactly what you want in your model. The main thing is going to be when you do an automated ML, it's going to be cycling through a lot of different models or algorithms for you. So they're iterations. So you can tell it how many iterations you want, after how long you want it to time out. So I've put 2 minutes in. What's going to be your primary metric to figure out what the best model is? You can pick your first one. You can pick more than one. Have a look at the docs to read through exactly what you need for your model. You want to say if it needs to be pre-processed. If you're already doing a lot of pre-processing and you don't want any further ones, you can say that false. And you can put cross-validations in there as well. So once you've defined exactly what you want, tell it exactly what to do, which is, again, your tasks. Is it regression? Is it predict? Or is it classification or time series? Once you've done that, you basically tell it to go. So you say, submit your local run, and it starts learning. And you can actually see it start learning because it starts printing out exactly what pipeline it's going through. So these are the different algorithms it tries out. And you can see how long each of them take to go through your data. And the metric that you have chosen, it'll actually track it. And also it'll track the best one as it goes. So it was trying all these different ones. The best one is still the first one it tried. And it'll keep going after that. And it'll only show you exactly how many you've asked for. So I only asked for 20. So I think it showed us 20 in there. There's a few warning signs. I think that was when things are getting moved around, when the product was a little bit still under previews, things are getting deprecated, just renamed into different things. And once you've got that, you can actually check out your results and pull your thing in, find the best model, and test the accuracy of that model that you've created really quickly as well. Get your Y predictions out, maybe run a root mean squared error, so your RMSEs. So it's only $4.9, about $5. I'm like, it's kind of close, pretty much there. But what's my percentage one? I don't really know overall. So that's about 15% absolute percent error that it gives us as this model. So the accuracy is about 86%, which, look, for a first run with absolutely no like actual tuning involved, bar just cleaning up your data a little bit, that's really, really good. And now once you've done this, what you can do is take this model and off you go, make it much better. Tune that, you're really tune that yourself, get that accuracy all the way up to 95% if you want it, or even higher if you can, that'd be great. But the kind of whole world is available and open to you to do what you want from here onwards. Have at it, go crazy. I put this in here because I'm like, clean up your resources so that you don't get charged. Once you are done, make sure you turn things off, turn off your compute, turn off, if you're not using your storage, turn them off. There's no point getting charged for things you're not actually using. So with that, what we went through was how do we set up an automated machine learning with no code, how to do it with code, and how to actually, a few tips and points of where do you go from there and how you can make the most of it. So coming back into our slides, kind of did a little recap while I was in there. But what I hope you have gotten to see from our agenda for today was how easy it is to use automated ML. Kind of basically did a whole thing in front of you. Sorry, the actual notebook wasn't live. And also, I don't really trust the Wi-Fi to work for me if it's really, really live, where I'm running the cells as I go. But it is, in that sense, fast enough that I could probably actually do that live within the session, and it would be running as we go and we talk about it. And other than that, I just want you to see how easy it is to actually use Azure Machine Learning Studio as a platform and a workspace for collaboration, and just everything connects up to itself, and it's kind of neat and clean and all in one place. And I really, really hope that someone goes and actually tries this and then lets me know. So with that, I will stop talking and hope there's someone listening at the other end. If you've got any questions, let me know now. I'm happy to take them, or my Twitter is there at the bottom of that page as well. Reach out to me. I'm usually more than happy to help. If I haven't replied, it's most likely I just haven't seen your message, or it's kind of slipped through, so just ping it again. I will not be offended.
That was a great session, Akanksha. Thank you so much. So we have this question for you. Hey, Akanksha, I'm right now a student and I'm aspiring ML engineer, data scientist. Do I have to worry about AutoML? Are there any space for us to work in ML domain in future? Is there any space? So this is asked by Abhinav Prakash.
Cool. No, it's a great question, Abhinav. But yeah, I think it goes back to machines are never really going to be able to just completely take over the world, as much as we kind of say that they will and hope sometimes that they will. Like, please just do my job, but like also please don't. It's that tough pull and pull. But again, no, automated ML is great to reduce your workload, which is essentially what AI and anything to do with it is what it's being used for, right? It reduces your workload and your costs involved with it, but it can't replace you. It still needs to be told what to do. It still needs to learn how to do it. And even when it does it, it's not always correct. I think this is kind of where the whole responsibility comes in, and making sure there's not biases involved. That is a huge problem in AI that a machine is never going to understand. I think people have heard about like the, I think it was the CVs. Some big tech company was using an AI, like an algorithm to read through CVs. And what it was finding was the fact that it was not favoring women at all. And that wasn't because it was biased against women. It was just biased on the data. In the past, the company only ever hired men. So it only thought that men were the better candidates. And a machine will never understand the difference or the nuance there to know how to fix that. A human will. And that's where us as data scientists come in, to make sure that there is still the human part of that understanding and how to actually make it work for us still there.
Of course, that is why the responsible AI. So Abhinav asks one more question to you. Is AutoML a little bit more computational costly for training models against huge data set? Because for finding best model, it has to try different models in against this huge data set.
That's actually a really, really good way of putting it. I haven't tried it necessarily, say, on really big things, but again, if cost is the issue, you can look at it the way of, this is technically saving you cost or dollars because it's saving you time. Instead of you going through 50 different algorithms locally on a smaller data set, a machine's doing it for you. I mean, if that is the case, you can see whatever data set you were going to use, a smaller one to run this locally, you can just use that same size on the platform and it'll reduce your cost. There's loads of ways around that kind of stuff. I mean, instead of using the full data set, if it's a year worth of data set, only use a month just to find maybe the top couple of algorithms. Sorry, algorithms, models, all these words keep jumbling into my head now. It's like 10 p.m. here. So I'm like, oh, what am I talking about? But you find your best algorithm. And from there, you can actually really start training into those specific ones afterwards. So there's ways around it. You'll have to figure out whatever works for you and your budget.
Okay, so Akanksha, we are having a best question round session. So our sponsors pact is giving mastering machine learning algorithm free ebooks to the best question, to the person who shall be asking the best question. And I would like to tell that for our first session, for event session, Lipsita is getting that. And for the second session, Raj Shankar Tiwari is getting that. So it would be great if you would announce that for Abhinav as well.
Oh, perfect. Yes. No, those are both really, really good questions that actually made me think. And I'm like, I haven't thought about this. So yes, well done, by the way. That sounds like a really good course.
So that's great, Abhinav. And it would be great if you can just put your email ID in the chat section, Abhinav. So, and thank you so much, Akanksha, for such a great session. I'm sure, I don't know about others, and I'm sure that our attendees are going to try this model, and even I'm going to try out this model, and I'll reach out to you.
Yes, please do. That would genuinely,
yes.
I'm sorry, at work, I will be a goddess. It'll be amazing. Because I'm like, yes, people did what I told them to do. But I'm joking. It would be great if people do actually go make something out of this presentation. So that's great to hear.
Of course, we'll definitely do that. So thank you so much for presenting. Thank you so much for
coming. Enjoy the rest of your day. Sounds like a really good day planned ahead.
Okay, yeah, of course. I guess this is night for you. So have a good night.
Thank you so much.
Okay. Thank you, Akanksha.
Bye.
So for the next session, I would like to invite our speaker, Jamie, for drag and drop chatbot development using Bot Framework Composer.
Yeah. Hey, everybody. Thanks for joining this session. And my name is Jamie Maguire, MVP in AI, building a lot in the chatbot and AI space. And today, so I'm just going to share my screen. Okay, can everybody see the screen? Is that good? Yeah? Okay, good. I'm just having a few technical issues here. So, right, screen's good. Let's get started. So in this session, what I'd like to share with everybody is an introduction to chatbots and Bot Framework Composer. And what we'll cover in the next 20 or 25 minutes is we'll take a look at traditional chatbot development, and we'll see how Bot Framework Composer has effectively democratized the chatbot development effort here. Next, we'll take a look at building a simple chatbot with Composer, and then we'll see how we can test chatbots. And finally, we can look at some tooling called the Bot Framework Emulator that lets us, navigate and cruise around the chatbots that we've built. So what's involved in traditional chatbot development? Now, it's important to look at this before we jump into Composer, just to get an appreciation for what the tooling is actually doing for us. So when you're building chatbots, you've got about 5 different types of dialogue that help you orchestrate your conversational logic. We've got containers, components, waterfalls, prompts, and adaptive dialogues. Containers and components tend to be used for constructing lower level dialogues and real customized conversational logic that you need to serve to your users. Waterfall dialogues are some of the most common dialogues that are used in chatbot development, and the reason being that they are very simple to implement. They follow a sense of linear steps, and they're just easy to conceptualize when you're constructing conversations. A little bit further down, we've got prompt dialogues, and these are the in essence, these are like micro dialogues within their own right, and these are like the lower level primitive dialogues. They help you capture numbers and dates and perform validation and all that sort of cool stuff. And then finally, we get down to adaptive dialogues, and these are a recent addition in the last 6 to 12 months in the bot framework. And this is actually what Composer uses under the hood. And with adaptive dialogues, these are they're really powerful in the sense that you can create dynamic events and create really customizable and complex conversational logic. So what we'll do now is we'll jump out of the slides because I don't want to do death by PowerPoint, and we'll jump into Visual Studio. So here, what we're doing is we are in a Visual Studio chatbot solution. if we look up to the top here, we've got a dialog called user profile dialog, and it inherits from the component dialog types that we just looked at earlier. In this line here, what we're doing is, in the constructor, we're setting up a property to let us manage the state or the internal state of that chatbot. And then in between lines 26 and 34, that's where we're setting up the waterfall steps that we just, I do apologize about the noise, that's my son going crazy on Mario. 26 to 34 are where we set up the individual steps that form this dialogue. So here we are, so here what we're doing is, in this particular dialogue, we're capturing user information. So we're capturing the transport type, the name. We're asking the user to confirm their name, the age, if they want to upload any pictures, and then if we want to confirm that input, and then finally we output all that data at the end in a summary. If we scroll a little bit further down here, between lines 38 and 43, these are the prompt dialogues that I spoke about earlier, and these are the discrete steps or the discrete data types that we have to capture as part of this conversation. So when we are asking for the transport, we need to capture a text prompt, and that's what we can see in line 39. I won't go through all of these, but when we get to line 46, what we're doing there is basically saying, okay, right, we've set up the dialogue, now we want to run it. And the way that we do that is just by passing in the name and assigning the initial dialogue ID. So that's the sort of the ceremony that's involved in terms of setting up a quote-unquote traditional dialogue. If we take a little bit of a closer look, though, you might be thinking, well, how does the data get sent backwards and forwards between the various steps in the waterfall? So if we right-click and go to the definition, so we'll see here, this is the first waterfall step that we run, and that's what we call each step or each method in the waterfall. It's called a waterfall step. So what happens here is we're saying in line 53, present the user with a choice. And then further down here, what we're saying is, this is the prompt that we want to give the user, and these are the options. So this particular choice prompt is going to give us the possibility of selecting either a car, a bus, or a bike as the input options. If we scroll a little bit further down here, we then take that input method, that input from the previous step, from the state, which is the transport type that was input, and then we ask the user another question, which says, please enter your name. Okay. I won't go through all of the steps, but you can see how these steps are executed in a linear fashion, one by one, and that's where it gets the name from. Like a waterfall, it runs from top to bottom. So if we scroll down all the way down to the bottom, we'll see here that we get to the summary step, and then we take all the data that was input previously in all the other waterfall steps. Then what we do is we just output that to the human in the conversation. So if we scroll back up, we can see that there's quite a bit involved here in terms of setting up just one dialogue. Now, you're building a chatbot, chances are it's going to be doing loads of things, and you will need loads of different dialogues to model that conversation. If you were to try to model an entire conversation in one dialogue, it would soon get messy. You would end up with a monolith, okay? And we don't want to do that. So that's traditional chatbot development. So what we'll do now is we'll jump out of Visual Studio, and then we'll jump into Bot Framework Composer, and we'll see how different that is and how little code that we actually have to write. So this is Bot Framework Composer. Before we get stuck into building a simple chatbot, it's probably a good idea just to take a look at the designer and have a quick run through of the tooling and what the various options do. So, and the way that we'll do that will be by clicking on a new project, okay? And you've got a bunch of templates that you can pick from, but for the purposes of this demo, I am just going to select create a project from scratch. We'll give it a name. Composer is going to do its thing, and then here we're into the action. So going from left to right, we can see that we've got 4 distinct columns here. So this section here is where we can navigate the menu options and get access to things like the home menu, the designer canvas, the responses that the bot can send, the inputs that the user can supply. More recent additions to Composer are integrations with other AI services, such as a Q&A maker service. We get notifications that let you know if your bot has got issues in the designer, and you can publish it to Azure. And finally, another more recent addition are the skills capabilities that are new to the bot framework. And skills are effectively microbots within their own right. And you can have basically multiple instances of skills, all serving different or solving different problems in your business. This column here is where the dialogues are added. Now, at the moment, we've only got one, which is empty bot. Down beneath there, you can see a little lightning bolt called greeting. That lightning bolt is an event, and this is the default event that gets set up when you create a new chatbot. This big bit in the middle here is the designer canvas, and this is where all the action happens when you're building your chatbot. And as you start to build out your conversational logic, you'll see this fill out with a bunch of flowcharts, and we'll get to that in a little minute. And finally, over in the right-hand side here are the properties panes. So as you drag and drop your widgets into the designer canvas, you can update the properties of this pane here, and then that will help you manipulate the properties in the widgets. So we can click on the event, and what we can see here is we've got this base event here, and this is just a welcome message that gets fired when the bot spins up. Now, it ain't going to do that much, so what we'll do is we'll add a new dialogue, okay? And we've seen how to do that before in code. There's quite a lot of steps involved, right? So, but in Composer, it's a completely different ballpark. So we do that by clicking on add and then a new dialogue, and then here what we'll say is we will create a dialogue that basically gets the user information, which is kind of similar to the dialogue that we looked at earlier. What we get is we get this new dialogue appearing up here. We click on the event, begin new dialogue, and we'll see here, this is the event that will fire when this dialogue begins, okay? Now, we don't have, it's not going to do anything because we haven't written anything at this point in time. So what we can do is we can just, if we want to send a message to the user, we just click that note there, add send a response, and there's a whole other bunch of options here, and I won't go through all of them, but there are, and these nodes are called activities, right? So there's a bunch of different activities for all the different use cases that you could ever have to code against. So there's activities to send a response, ask a question, create loops and stuff like that, or create business rules and logic. So we might just want to say, please enter your name. Now, this is just a send response, so that's just going to send a message. That by itself isn't very useful. The way that you have to deal with inputs in Composer is by using a different type. We can do that again just by clicking here, ask a question, and we can say we want to ask a text question, and we get a new set of activities here. And this is a pairing. So the first part of the pairing is the prompt, and then the second part of this pairing is the user input. So we will say, please supply your name. Okay, now that's just going to set the prompt part up. But what we have to do is grab that input from the human, and we do that by clicking on the user input node, and we see that the pane over in the right-hand side has changed. And the key part here is we have to store this value. And the way that we do that is just by, like regular coding, is just assign it to a variable. Now, in Composer, just like any other development language, you have got a few different ways to scope your variables. Some of the most common ones are the conversation. scope, the dialog scope, and the user scope. So user scope basically means that variable will be accessed or accessible by the user throughout the entire session, but just for that particular user. Dialog scope is available to everybody, but only as long as you have an active dialogue, okay? And that's the one that we're going to use. So what we'll say is we'll add this to the dialogue and we'll just call that username. So we're saying here, we want to take the user input and store it in the property dialog.username. So dialog is a scoping, username is the actual variable name. And finally, there's another tab here called Other. We'll click on that and we'll go down to prompt configurations, and there's a value down here that says always prompt. And more often than not, you kind of want the prompt to always be asked. So I'm going to set that to true. Now, we've created a simple dialog here where it's called get user information. That's going to send a message, then it's going to prompt us and then take that input. That's all fine and well, but what we need to do is we need to call that from somewhere. And the way that we do that is by invoking this dialog, and we'll do that by going into the default event up in the greeting link here. We'll scroll down. After the bot has welcomed the user, we want to start our new dialog called get user information. So we can do that by clicking here, selecting begin a new dialog. Over in the properties pane to the right hand side, we'll click on here and then get user information, and that's it set up now, right? So we've only clicked a few buttons here, right? So before we seen there was quite a bit of code. Now, okay, there were quite a bunch of different steps involved, but we had to pass the state around there. We had to perform that manual plumbing of passing the data from one step through to the next and the next. With Composer, you don't have to do that, right? And we'll run this now, and we can do that just by going up to the top right here, clicking on Start Bot. Composer is going to do its thing. It's going to pack all of the assets that we've just created in the designer canvas. When it's done that, a link will then activate. And what we'll see is we get an option to start another tool called the Bot Framework Emulator. And it's taken a few moments, but what the Bot Framework Emulator is a thick client, and it basically lets you test your chatbots without having to deploy them to Azure. You can either run the Electron app, which is the one that I'm going to be showing here, or you can host the web chat instance of it, the web app instance from, and you can pull both versions down from GitHub. So we're just getting a firewall notification message here. So we're just going to allow access to the Bot Framework Emulator. And it's just loading up here. So here we can see our bot started up. We've got the welcome message. We've got that prompt that was just a message that we sent. And we've also got please supply your name. Okay. Now, we've actually missed a bit here because the other part of the demo was I want to output that response back to us just to prove that we're capturing the input. And the way that we do that is we click send a response. So we're adding another node here. We just say hi. And then there's a little bit of a notation here where it's dollar and then parenthesis. So we're basically saying hi and then the username. So what we'll do is we quickly have to restart the bot. Takes a few moments again. And what we'll see is when we start the Bot Framework Emulator this time, we'll get that message, we'll supply our name, it'll get read into the value here, and then we'll output that, okay? Now, this is a really simple chatbot, right? So when we see this running, like in the real world, it's a useless chatbot, right? I fully admit that, but what we're seeing here is a bunch of different concepts, okay? So we'll pull it up side by side. And what we'll find out here is we're getting the welcome message, which comes from the greeting. we're getting please enter your name, and then we're getting the prompt this time that says please supply your name. So I can key in my name, and then it's just outputting the response back. Now, using this, you can sort of see how you can start to build up in daisy chain the dialogues and the prompts to build conversational logic, right? Now, as I said earlier, in the real world, like let's get real, this chatbot would be useless, okay? The real power of chatbots, and on one side you get the logic, but personally, I feel that the real power comes in when you start to augment your chatbot's intelligence with business rules or APIs or external systems, okay? And the way that you can do that is by breaking out and making HTTP requests in Bot Framework Composer, and that's what we're going to look at next, right? So I've got another quick demo here. I'm gonna close the emulator again, and we're going to jump out of this simple chatbot. We'll go back into the home page, and I got another chatbot here and what we'll see here is the fundamentals are pretty similar. Okay, we've got a greeting here. We're just looping through anybody that joins the conversation and welcoming them. But we're handling this unknown intent. Now, we never touched on intents, okay? So intents are basically the actions that the person has to or wants to carry out. Now, the good thing about Composer, right, is that you don't have to build up a language understanding model or natural language model to get started, right? But in the real world, what you would do is you would create a natural language understanding model and sit that in front of your chatbot, okay? And that language understanding model would be trained to recognize particular phrases or basically utterances that people can supply. It's good practice to create a bunch of different intents that map directly to the business functions that you have to build your chatbot against. And then in between that, create 20 to 30 example phrases of each utterance, okay? So you get your language model that sits on the front of your chatbot. It passes out the initial request or the utterance that the human wants to basically carry out. And then the language understanding model picks out all the key data points that are important and then takes that unstructured human text and converts it to structured information that makes it easier for the chatbot to work with. And a part of that process involves mapping it to an intent, right? Here, we're handling an unknown intent. And what that means is that the language understanding model hasn't been able to identify a suitable intent. A common pattern is to use the unknown intent as kind of like a bucket for all the other intents that can't be identified. And you might have like a Q&A maker service that tries to get the user back on course for the conversational process. But here we're just using the unknown intent, right? But what this chatbot does is it connects to the Twitter API, okay? And it asks the user for some input. It grabs that input. It then asks it's going to ask us how many tweets that we would like to extract from the Twitter API. It's going to grab that. It's then going to make a request to the Twitter API using this HTTP requested module. And as I touched on earlier, this is where you can really augment your chatbot's intelligence, because this designer canvas gets really busy. So what personally I think that I like to do is to break up the conversational AI into a bunch of different dialogues, and then where the logic is really complex, I'll host that in a dedicated web API and break out into that API, pull the data back in. And what we can see here is one of the properties are the URL. Here, we're taking the number of tweets that we want to fetch. We're passing that in as the count. And then the final part is we're sending in the query and passing that in as part of the request also. What we then do is take the response back from the Twitter API. We store it here, and then we look through that and basically send out all the tweets, all right? So that's it in a nutshell. We're taking some user input, calling out to the Twitter API, grabbing the data, and then cycling through that and then outputting it into the chat window. So the way that we test it is simple. It's just the way that we've done it by before. We click on the restart bot button. That Composer's going to do its thing. We're doing a little bit extra this time, so it may take a couple of moments to spin up. And we've got the link active here, which is good. So this is the bot framework emulator. It's going to spin up. The chatbot will greet us, where we should get a sort of welcome message. No, it never gives a welcome message for some reason, but that's okay. The key part is here is enter a search term. So I could say AI global tour. And this is real time, so warning, I cannot guarantee the content that the Twitter API will return, okay? We'll say how many tweets, we'll say 15, and it's breaking out at this point, and we can see there's a whole bunch of different tweets that have been brought back from the Twitter API. Actually, there's one here that somebody sent, tweet catch me live at the global AI tour. There's actually one that I sent out earlier this morning, which is pretty cool. And if we click on that link, yeah, we clicked on the link, and then we can see here's a blog post that I put up this morning talking about the event that's happening today. So that was a quick run through of Bot Framework Composer. What we've seen here is we've seen how different it is from traditional chatbot development. Sorry, my son's popped up for a cuddle. How traditional chatbot development is totally different from regular chatbot development. We've seen how little code you have to write, and there's a whole much more to go at with Bot Framework Composer. Some of the things that you can do are blend your Bot Framework Composer chatbots with traditional chatbot development. So what you can do is that you can have your coders building out the low-level C# and all that sort of stuff, and then you can have maybe a support person, business analyst, product owner, building conversational flows in Composer, and that kind of means that you can build your chatbots in a parallel fashion. Composer's really democratized the chatbot development, because you don't really need to be that technical to build chatbots. It's not out with the realms of possibility to take a PowerPoint presentation or Visio diagram and then just jump straight into Composer and model it that way. People may need a little bit of technical training with it, but you sure as hell don't need to understand state management, passing data around. You need to know a little bit about variable manipulation, but highly encourage anybody to check it out who wants to quickly get started, because you don't even need to build a language model initially. And that's one of the things that I personally really enjoy about building with Composer. I've got a bunch of blogs on my website. I've got about 5 or 6 different articles that will take you through the higher level overview, right through to some of the low level mechanics of sharing state between a Bot Framework Composer chatbot and a regular chatbot. There's loads of other cool stuff there as well, so feel free to check that out. So I'm going to wrap up here. I'm just conscious of time. I don't want to bleed into somebody else's session. I hope everybody's got some value out of this session. If anybody has any questions, feel free to dump them into the chat. If nobody has any questions at this point in time, feel free to contact me either on Twitter or directly on email, and I'll be happy to answer them. So at this point, I'd like to just open the floor up to any Q&A that people might have. So thanks everybody for their time, and I hope you got some value out of this session. So thank you.
That was a great session, Jamie. So we have the questions for you. From Abhinav Prakash. Can we deploy the bot created by Bot Framework Composer in mobile or edge device, as we are using the tf.lite, or we have to deploy it on the cloud? Right.
So that's a good question. So thanks for that. your chatbots can be hosted in a range of what Microsoft call channels. So one of those channels is a web chat instance, which is responsive. Okay, so that's one place you can host your chatbot in. So some of the other channels include Twilio. You can communicate with your bot via SMS. You can WeChat is another. So in terms of an edge device, like an IoT type thing, not so much, but you can certainly integrate your chatbot with a whole bunch of different services. So what I would encourage the person who submitted the question to do would be to go on to the Bot Framework website, and what you will see will be about 15 or 20 different channels, right? Now, I don't remember all of them off the top of my head, like full disclosure. I mainly focus on web chatbots, bots that can be served over the internet on a website or on a mobile device, okay? So the web chat component is fully responsive, and you will be able to interact with your chatbot on a mobile device or a website. But if there are other edge devices or other resources that you want to host your bot on, then certainly check out the documentation.
Okay, I suppose that answers Abhinav's question. So next is from Aman Raj. Is making conversational bots through Bot Framework Composer easier than making conversational bots using Rasa or Dialogflow?
Okay, so I can't comment on Rasa or Dialogflow. I am aware that other vendors are creating similar products. Yeah, so and what I've found is that there are lots of similarities. Okay, like you got to interpret like an utterance. You've got to map that utterance to some business process or some dialogue or some bit of conversational logic. Now, what I've seen, for argument's sake, that there's another big vendor who they do a lot within the telecom space, and they have a kind of like a chatbot studio thing. The experience looks the same. I just can't comment on the other two. I haven't used them. It would be unfair for me to say, yeah, it's easier or simpler, because I can't compare, unfortunately. I'm using Composer daily. I'm an engineer with 20 years experience, and like I got to be honest, man, for like the last few weeks and months, I haven't had to write much code when building my when building my chat.
So we have a sweet guest. We would definitely love to meet him, sir.
All right, do you want to wave to the camera? No, he's shy. Hey. Right. So yeah, hey, it's the modern world, right? So yeah, it's Spider-Man. So
he's really cute, sir.
Oh, thank you. And he gets that from me. Try them out, man. Try them out. Like I'm heavily invested in the Microsoft space, right? And it just works for me. Like it plays nicely with Azure. It can deploy directly to Azure. I just think it's a great tool. Like as I said earlier, I haven't had to write much in the way of code because I laid the foundations. And I talk about some of this in some of the blog articles. Okay, like see being able to break out into APIs and stuff. It's so powerful. It's so powerful because you can have parallel development streams. You can have people modeling up the composer dialogues, and then you can have somebody else working on the low-level API stuff. And as long as you both agree to a contract of inputs and outputs and data getting sent backwards and forwards, then it just works as a development practice. So try them all out. Find the one that you like.
Okay, so Jamie, we are having from our pact, the sponsors are giving the best question. The person who's asking the best question for the session shall be getting a Mastering Machine Learning Algorithms book, second edition book. So you would like to give it to? I mean, you had two questions, Aman and Abhinav Prakash. So you would like to give it to? I would like to tell that Abhinav has already won one of the books for the last session.
Right. So I think it would only be fair for the person who hasn't won to. They were both great questions, by the way. You know, the questions were great. So happy for the person who hasn't won yet to get it.
Okay, so it shall be given to Aman for your session.
Yeah, Aman's fine. Yeah, that's fantastic.
Okay, so that was a great session, Yami. Thank you so much for joining us, for joining our event and giving such a beautiful session.
You're welcome anytime. And if anybody's got any questions after this, just feel free to reach out. It's totally fine.
Of course, I'm sure our attendees would reach out to you. Thank you so much.
You're welcome. Thank you.
So I would like to tell our attendees that we are having this quiz session going on, which you must attend. I shall be sharing my screen and showing you the quiz that we are having. So I hope you can see my screen. No. Okay, yeah. So this is the quiz, and the top 5 scorers of the quiz will be receiving an exam voucher award from Microsoft, and that vouchers will be applicable for the 70, 74 and MB series examinations from Azure, as well as the new role-based examinations, but it shall not be valid for the AZ900 certifications, which is their fundamental certification, and this certification shall be valid only in India. So keep that in mind and keep going for this quiz. This quiz shall be receiving the responses only till 8:30 p.m. today. So you are requested to fill this as soon as possible, and the link is available in the description box. So you can just go for the quiz. And taking our event further, I would like to introduce our next speaker for the session.
Hello.
Hi, Håkan.
Hi, how are you?
I would like to invite Håkan for the machine learning in browser with tensorflow.js. So you can go ahead, Håkan. All the best.
Yeah, thank you so much. So let me just share my screen here. So, great. So, welcome to this session where I will be talking about machine learning in the browser with TensorFlow.js. So, just a little bit facts about me. So, my name is Håkan Silfvernagel. I work as a manager for AI and big data at Miles, a Norwegian consultancy company. And my background is in human-machine interfaces for process automation and robotics. And my educational background is a master's degree in electrical engineering and a master's degree in behavioral science. I'm quite involved in the local user group community here in Oslo, so I'm part of the Norwegian.net user group. I'm also part of Oslo AI, and I am part of a new initiative, a new AI school. So if you want to know more about AI and learn about that, you can follow AI42. I've started together with a colleague, an MVP colleague called Eve Pardy. And I'm also a Microsoft AI MVP, and you can find my social media information on these links. So now the agenda here for today is first I'm going to give all of you like a basic introduction into machine learning so that we're sort of on the same page. And then after that, we're going to go more into TensorFlow and more specifically into TensorFlow.js. We're also going to have 2 demos here. The first one, we're going to build a TensorFlow.js application from scratch in our browser. And we're going to train an algorithm and we're going to run it and make some predictions. And in our second demo, we will make use of an already pre-built machine learning library and make an image classifier. But first up, what is machine learning? So machine learning dates back to the 1950s, and Arthur Samuel, which is called the father of machine learning, he said that this is the field of study that gives computers the ability to learn without being explicitly programmed. But I can say that machine learning is a lot about finding patterns in historical data. Some of the applications of machine learning can be predictions, it can be recommendation systems, it can be clustering or image recognition, text recognition, or speech recognition. And one way that we can do machine learning is called supervised learning. So with supervised learning, we are making use of historical data and the result, the historical output. And by using these, we can build a model, and then we can train this model so that it can take in new real-time data, and then it can give us back a recommendation, for example, or a prediction. And we have a couple of technologies here that has made AI very popular now today. So one of them is sensor technology. We have access to cheap sensors that can give us real-time data. And we also have big data solutions so that we can we can load and we can transform all of this data in the cloud. And we have machine learning services that we can make use of. And for us as developers, we can use all of these through the cloud. And just for completeness, it's been mentioned a little bit earlier today here that there are two main languages. One is Python and the other one is R. But basically, you can do machine learning in any type of language. But you don't really want to start out from scratch. You want to work in an environment where you get a lot of support with already existing models and functionality. So Python is typically more used within people coming from a computer science background, whereas R has been used more in an academic background and people with a statistical background. So what is TensorFlow? So TensorFlow is an open source library that was developed by the Google Brain team, and it expresses its algorithms using something called tensor operations. And one big advantage with TensorFlow is that it supports distributed computing, which is great if you want to run neural networks, for example. But what is a tensor here? So tensor is a concept from mathematics. So in mathematics, you can distinguish between either a scalar number, which is a real-time number, or a vector, which is a collection of numbers, or a matrix, which is like a two-dimensional collection of numbers. And then we have tensor. So tensor is just a container where you can store either scalars or vector or matrices. So TensorFlow is working with tensor sets as its format. So if we would have used this in a notebook, then we can import TensorFlow as TF, and then we can start up a new session, and then we can define two constants, 10 and 32, and then we can just print it out on the console what is session.run for these two constants. But now the topic for today is TensorFlow.js. So TensorFlow.js is a JavaScript library so that you can both train and deploy your models in the browser and on Node.js. So let us start with our first demo here. So let me go over here to the browser. Or actually, I can start out in Visual Studio Code. So here in Visual Studio Code, what we have here is we have just a simple HTML page. And what we do here is we import the TensorFlow JavaScript library, and we also import something called the TensorFlow visualization component, which is also a JavaScript library. And then the main action will take place in this script.js file. So if we have a look at that file right now, we're only doing a console log out on the console hello TensorFlow. So if we run this in the browser, like this, we can see that it's printed hello TensorFlow, so we know that this is working. But then we need to have, a problem where we think that machine learning can be a good candidate to solve this problem. So we need to have access to some sort of data. So luckily for us, we have here a JSON file with some car data. So in this JSON file, we can find the name and the model of the car, the number of cylinders, and the miles per gallon, and the horsepower, and among other things. So what we would like to do here is we would like to load this JSON data into our JavaScript application, and then we would select some of these entities here and see, can we predict one entity from the other or one feature from the other? So let's start here with loading this thing into our JavaScript application. So we're going to add some code here into our JavaScript file. So this is get data. So what we do is we do a fetch on the JSON file, and then we clean out. So what we're interested in here is the miles per gallon and the horsepower. And we want to know, can we predict the miles per gallon dependent on the horsepower here. So we extract out the miles per gallon and the horsepower, and then we clean away the null values because we don't want to have null values, and then we return the cleaned data. Then the next thing that we want to do is we want to find out, is there actually any type of relation here between miles per gallon and horsepower? So we want to do a plot here. So then we can define a function. So we define a run function, and first we get our data by get data, and then we map out. So we will get on the x-axis, we get horsepower, and the y-axis, we get miles per gallon. And then we use this TensorFlow visualization component in order to render a scatter plot. So we'll render horsepower versus miles per gallon. And then we will add more code as we continue with this example here. But let's start with this. So we save this file, and then we go back to the browser, and we run this. So now we can see here on the right-hand side in the browser, we get a scatter plot of horsepower versus miles per gallon. And then luckily for us, we can see that there actually seems to be some sort of relation here between miles per gallon and horsepower. So the higher the horsepower, the less miles per gallon. And that's a good thing, because that means that this is a relation that we can use a machine learning algorithm to learn. So if we would have found out that there is no relationship, that all of these data points are scattered all throughout our scatter plot, then it would have meant that there is no relationship. So there is nothing that our machine learning model actually can learn. So that would have been a bad candidate for machine learning. But now, as we see here it seems that there is a relationship. So that's a good thing. Then we can use this in order to train a model so that we then can do a prediction. So basically what we want to do is we want to train a model where the input is horsepower and then the output or the prediction is the miles per gallon. And what we'll do with that, we'll use these values and then we will feed them into a neural network. And then this neural network will learn from examples so that it can be able to predict miles per gallon from horsepower. And this is an example of supervised learning that we were looking at in the PowerPoint presentation. So the first thing that we need to do here is define the model architecture. So the model architecture in machine learning terms is an algorithm that will take an input and produce an output. So in this case, we will use a neural network. And here the algorithm is a layer of neurons with different types of weights that will decide what the output will be. And when we train, during the training process, this algorithm will learn the best values for these weights. So we need to add the function here so that we can create our machine learning model here. So let's go back to Visual Studio Code. And then we go up here. So in this function, the first thing that we do is we create a TensorFlow sequential model. And this is one of the most simple models that we have in TensorFlow.js. And it's called sequential because the input flows straight down to its output. But of course, there are much more complex models where you can have multiple inputs and multiple outputs and also have branches in your model. And then we add an input layer. We add a single input layer to our model, which is a dense layer. So a dense layer is a type of layer that multiplies its input with a matrix, or that we call weights. And it also adds a number that we call a bias to the result. And this is the first layer of the network, so we need to specify the input shape, which is, in this case, is 1, because we only have one number, which is this horsepower of the car. And then we set the units. The units will set how big will this weight matrix will be in this layer. And here we set it to 1, which means that there will be one weight for each of the input features of the data. And then we create our output layer, where we set also the units to 1, because we want to have one number as the output. And then next we need to create an instance of our model. So let's go back to the run function, and then we add some code over here. So here what we do is we create our model, and then again we're using this TensorFlow visualization component in order to show us a model summary. So we save this file and we go back to the browser. And then we rerun this, and then we get our plot, scatter plot, and then underneath we get the model summary here, which is what you would have gotten in a Jupyter notebook, for example. So you can see how many layers you have in your model, what is the output shape, the number of parameters, and if it's trainable or not. So far, so good. So the next thing is that we need to prepare the data that we have for training. So the first thing that we need to do is we need to convert our data into tensors. Because remember, I was saying here that TensorFlow is only working with tensors as a format. So we need to somehow convert our data so that it is in the tensor format. So let's add a function here, convert to tensor data. So we go back to Visual Studio Code. And then we add this function here. So here we have this function convert to tensor. So the first thing that we do is we do two best practices here. So the first best practice is that we want to shuffle the data. And the reason why we want to shuffle the data is that when we do our training, then we will divide our data into batches. So when we train, we want our batches to be as representative as possible for the whole data set. And that's why we would like to have data from all across the data distribution. And it also has some further advantages. So one of them is that by doing this shuffling, we will not learn things that are only dependent on the order of the input data. And it's not so sensitive to structures in the subgroups. For example, it could be that maybe for some reason there is a high horsepower for the first half of the training data, and maybe that's not the relationship that is representative for the whole data set. And then we convert our data to tensors. We just use an inbuilt function, TensorFlow tensor2d, and then we get our input tensor and our label tensor. So the label is basically our output in this case here. And then we do something here which is called normalizing. So we normalize the data so that we get all of the data in the range between 0 and 1. And this is called min-max scaling. And the reason why we do this is because many of these machine learning models in the internals, they are designed to work with numbers that are not so big. And finally, we return both our data and also these boundaries that we found, the input max, input mean, label max, and label mean. And the reason why we want to return this is because when we've done our predictions, we need to be able to convert it back to the original scale. Then next up is we want to be able to train our model. So then let's define a function here, train model. So here first thing that we do here is we need to compile our model before we train it. And we also need to set some parameters for compilation. So one of them is the optimizer. So the optimizer is an algorithm that will governs the updates to the model as it sees new examples. So there are many types of optimizer available in TensorFlow. And here we picked the Adam optimizer because that is quite effective in practice and requires little configuration. Then we also need to define a loss function. So this is a function that will tell us how well the model is doing when it tries to learn on each of these batches. So here we use the mean squared error to compare the predictions made by the model with the true values. Then next we pick a batch size. So batch size is how big will this data subset be that the model will see. So some common batch sizes is range between 32 and 512. And in this case we've just selected 32. And then we select number of epochs. So the number of epochs is how many times will the model be looking at the entire data set. So here we will take 50 iterations through the data set. And then we start the training loop here by calling model.fit. And one nice thing that we can do here is we can define a callback, and then we can use this TensorFlow visualization component in order to do a printout here. So after each epoch, it will print out our loss function and our mean squared error. And now it's actually time to do our training. So let's add some code into the run function. So what we do is we convert our data to tensors first, and then we extract the inputs and the labels, and then we train our model, and then we just do a console log so that we know that now we're done training. So let's just save this and then switch back to the browser, and let's run this. And now if we have a look here, then we can see that here on each epoch, it will print out the loss function and the mean squared error here for us. So on the x-axis, we have the number of epochs, and then on the y-axis, we have the value which we want to have to as low number as possible. So now we've reached some state here, and then it is 0.065, for example. So let's say that we are happy with that number, and then we want to go on here. So next step would actually be to try out our model to make some predictions and see how well it does. So we will add a number here to be able to test our model. So let us add this. So if we go back to Visual Studio Code, like this. So what we have here is first we define some 100 new examples that we will feed into our model, and then the only thing that we need to do is we need to call model.predict in order to get our predictions. And then after that, what we do is we use this input max and input mean in order to do an unnormalizing of our data so that we can scale it back to the original scale. And then we return the unnormalized data here. And then finally, we can render all of this into a scatter plot, again by using this TensorFlow visualization component. Then we need to add a call here to our run function so that we can run this. So one moment here. So we just add here. So here we just run test model. Let's go back here. And now, since this is just an example, if this would have been real, we don't really need to print out our plot every time, and we don't actually need to do this training either every time. So, but one thing which is important here is to do some sort of monitoring so that we can see if our data has actually changed, so that our model is performing bad. Then we can do a retraining of our model. But here we can see that. So this is the predictions, which is right now a straight line. So the question is, can we get this any better here? Because we can see that it's clearly not a straight line; it's much more like a curve. So maybe we can do some changes to our model. So let us go back to our model in Visual Studio Code. So if we go back to where we define our model, which is over here, then if we comment this thing out, and then we add some new code here, we will create a new model. So in this case, we use this TensorFlow sequential model, but we add 2 more layers here. So we add one layer here with 64 nodes with a ReLU activation function, and another layer here also with 64 nodes with a ReLU activation function. So we call this hidden layers because they're in between the input layer and the output layer. And now hopefully this will be able to take into account this non-linearity that we could see in this graph. So hopefully this will give us a better prediction. So we save this, and then we go back to our browser, and then we rerun this. So let's see. And we can also see here that we got an update of our model. So we can also see how many parameters that are trainable. So in our second layer, we have 128, and then our third layer, it's 4,160, and so on. And we can also see here that we actually reached a better loss value and mean squared error here earlier. So we reached a good value only after 10 epochs. And we can also see here that we made a much more better predictions than with our final model. So what I would like you to take away from this example here is that you can get a lot of things done. You can do some some initial data analysis in the browser that we could see here. And we can get the printout of some model data, and we can also do training, and we can do a final test here of our model on live data. And we use the pretty much just inbuilt functionality in the TensorFlow library. So now let me switch over here to the slides. So another way that we can use TensorFlow is actually use pre-existing models. So we can convert a pre-existing model, which can be, for example, a Keras model in H5 format, to the TensorFlow.js layers format. And we can do this two ways, either from the command prompt by using this command, or we can use it from a Python API. And then we can just, after we've done this, we can, in our JavaScript application, we can import TensorFlow, and then we can just import our model, define model as await TensorFlow load a layers model, and point to where we have this converted model saved. But why would we like to use TensorFlow.js? So there are a number of advantages here. One is that we don't need to learn another language. We don't need to have a round trip between the client and server. And since the user data is local, you can claim that there is a higher security than if you need to transfer it over the wire. And in addition, we have the browser application, which is highly interactive and easy to use. And you also have easy access to sensors like the webcam and the microphone. So we have some already pre-built models that we can use. So these are some examples if you want to do image classification or object detection or what you want to do. So now in this case, we want to try out an image classifier. So let me switch over here to the browser and let me reload this here. So the first thing that we do here is we select an image, and then we can select a machine learning model, and then we only click predict, and then we get here the prediction that with 99.9% security this is a strawberry. So let us have a look at how this thing is actually done. So basically here we have this HTML file with just some options and some selections. And if you scroll down here, we can see that we import the TensorFlow library, and then we have an ImageNet classes JavaScript file that I will come back to, and then we have the predict file where we do the machine learning prediction. So what we do here is when we select an image selector, we read in the file, and then we whenever we change this model selector, we will run this load model function. And the load model function takes in this name of the model. So for example, this was ImageNet or MobileNet, and then we can see here in the MobileNet directory, we have this model.json. So the model.json was the result of a conversion of a Keras H5 model. Then when we do the prediction, we need to do some pre-processing so that we get this image into the tensor format. And then we can just run model.predict in order to get our output data, the predictions. And then, as I said, we also have a file here called ImageNet classes, because from the MobileNet, what we get is we get the probability, and then we just get an index. So the index is just a number, and then we need to convert that to a text string. So here is the numbers and the conversion from number to text in ImageNet. So that's basically all we needed to do in order to get us an image classifier. And this works also for, for any type of model that you have in Python. So you can convert it to this layers format, and then you can use it in your web application. So then finally, I would just like to take some examples here from the real world where people have used TensorFlow.js. So one of these examples is from Uber. So Uber, they have a tool they called Uber Manifold, which is a visual debugging tool where they use TensorFlow.js. And you can read more about that on the GitHub link that you find on this slide. Another example is from Airbnb. They have something they call the identity document detection. So when a user wants to upload images of a property that he wants to put onto Airbnb, maybe sometimes they put accidentally, maybe they forgotten to have a driver's license or a passport picture lying around, and that might contain personal sensitive information. So what they do is they run a machine learning model on the client side so that they can alert the user that this picture might have sensitive information. And then we also have from the music side, we have something called Magenta and Magenta Studio. So these are components that are using machine learning models in order to generate music. And then finally, I have some references here if you want to learn more. So you can both use the official documentation from TensorFlow, or you can also use the Coursera course. So there are many courses on Coursera which are great if you want to get an introduction to TensorFlow. If you want to know more about the image detection example, you can go to Deep Lizard on YouTube and find more about that. And there are also lots of code labs on Google's own web pages. So with that, I would like to thank all of you who were tuning in to this session. And if you have any comments or any questions, you can reach me on Twitter, on Grevlist, or you can send me a mail on this email address. And with that, I'm open for any type of questions. Thank you so much. And maybe I should also say that I can't really see the questions because I haven't loaded the YouTube page. So maybe
it's okay. I shall be asking you the questions. Okay. So the first question is from Abhinav Prakash. I have seen that there is a tensorflow.js converter by which I can create my model using TF, Python, and then convert it in the tensorflow.js format. So can I convert any model, or there is some limitation with it?
No, you should be able to convert any type of model by using this converter tool that I was showing here in the presentation. That should go fine. And that is actually one really nice thing here, because many companies, what they have is maybe they have like a data science department, and then they have like a web developer department, and a lot of times maybe the data science department, they can have problems in demonstrating their solutions because they only have the Jupyter Notebook to demonstrate it. But what they can do now is they can just convert it to this layers format, and then they can hand it over to the web development department, so they can just show it on a regular web page. So I think this opens up a lot of new possibilities.
Okay, so Swastik Mishra is having a lot of questions for you. So if I'm making a website which uses Node.js as a backend, which would be the preferable library to be used for ML in a long run, TensorFlow.js or Brain.js? Or should I use TensorFlow separately for just ML things?
As again, a lot of these questions is a little bit context specific, so it's really difficult, to give a right answer. But I think one important thing here with TensorFlow is that you both have TensorFlow as a Python library, and then you have TensorFlow as this JavaScript library that we were looking at now, and then you also have TensorFlow Lite. So with TensorFlow Lite, you can run things natively, both on Android and on iOS, but you can also run it on a microcontroller and small embedded systems. So that means that if you base your development on TensorFlow, you won't need to make a lot of changes if you want to expose your model in these 3 different scenarios. So I would strongly advise everyone here to have a look at TensorFlow, because it's very versatile, and it's also relatively easy to get into if you come from a developer background.
Okay, so next question from Swastik Mishra is, most people I have seen in the internet prefer working with TensorFlow.js than Brain.js. Even though Brain.js uses JSON objects, which does not put the developer in the hassle to create tensors.
Yes.
And make memory management and stuff. So why do people prefer working with TensorFlow.js even though Brain.js is easy to implement?
I think it can be a little bit things that I was talking about, that TensorFlow is very versatile. It means that both if you're a web developer, you can easily get the grasp on it. And if you come from a machine learning background, you probably have seen and used most of these functions before. So you don't need to learn, a new framework. And also, I also think that TensorFlow is like a standardized tool here. So if you have any problems, there is probably someone else that can help you out. So there's like this huge community of TensorFlow developers, which I think is an advantage.
Okay. So Håkan, we are having this contest for the best question that shall be asked to the speaker, and from our sponsors packet that is packed, we are that person shall be getting a free ebook of mastering the machine learning book. So whom would you like to give? You had two questions.
Yeah, I think I would like to give it to the last person. I don't remember. I don't recall his name.
So Swastik Mishra shall be getting that ebook. So I would request Swastik Mishra to please put his email ID on the chat section. So thank you so much, Håkan.
Yeah, thank you for having me.
There's one more question. There's one more question for you. Can we use quantization in TensorFlow like TensorFlow.lite?
Well, actually, in TensorFlow.js, I'm not really sure. I know about TensorFlow.lite, but I have to look that up actually. So yeah, I have to pass on that question.
Okay. Okay, sir. So thank you so much, Håkan. That's it. We would take.
Yes, thank you so much.
Thank you so much. Thank you so much for joining in for our event, Håkan.
Yeah, thank you so much for having me.
Okay. So now I shall be sharing my screen to show you. So now I shall be sharing the quiz that we are having. So our sponsors, Microsoft, shall be providing you with the top 5 scorers with the vouchers for the exams, that is 70, 74, and MBX series examinations for Azure, but that shall not be valid for AZ900 certifications, which is the fundamental certification, and this shall be valid only in India. So I would request you to fill this quiz as soon as possible. You can get the link in the description box. So Lipsita is asking for a declaration of the winners of quiz. So Lipsita, the quiz shall be open until 8:30 p.m. today. So after that, you shall be getting to know the winners of the quiz. I guess we have a bit of delay for our next session. So before that, let me show you the learning path that we are having, that Microsoft has provided us with. So for this global AI on tour session, Microsoft has shared 8 modules for which you can get the batches. So these are the 8 modules. Out of these 8, one module you need to complete. And then in the profile section, you need to go to the achievements. You need to take the screenshot of these badges and you will have to tag. You will first have to add the hashtag for Global AI on Tour BBSR, and you will have to tag Vivek Sridhar and Arakshit Saha so that they can reach out to you and you can have a chance to win the hero badge from Microsoft Learn. So I hope you shall be going in for this, because this is a really cool opportunity to get the badge that you can showcase anywhere on your social media, LinkedIn, Twitter, anywhere. Should we have to complete the modules today itself? No, Swastik, you don't need to complete the modules today itself, but make sure when you complete it as soon as possible. And once you complete it, you need to go to Twitter and share the screenshot with the hashtag, as I mentioned, and mentioning Vivek Sridhar and Arakshit Sahar. And only after that, they'll be able to get back to you. So we shall be taking a 5-minute break before our last session, because our last session is a really long session. It'll be a 1-hour session. So we would suggest that you can go and get a break and grab a snack time. Until then, we'll be back in the next 5 minutes. we are back. So I would like to invite Goran for the next session, that is Azure Custom Vision in Action.
Hello. Hi, nice to be here. Just give me a second to share my presentation. Now you should be able to see it. So today we'll talk about Azure Custom Vision in action. My name is Goran Vuksic. I work as a technical manager at Stratitech, and I'm Microsoft MVP and NVIDIA Jetson AI specialist. And overall, I work in industry for some 15 years. I think the story. I'm born 1980, where story begins, and just to give a bit of background, how I ended up here and why I like AI is I remember as a kid I wanted to be a pirate at some point of I was like 5-6 years maybe, and not software pirate. Those ships, swords, guns, and such. And but as all things in life, it quickly changed, right? As we grew up, so a few years later, I wanted to explore jungles, and it was probably Indiana Jones influence, the movies. But the thing is, I was thinking like, why is everything explored, you know? And the same thing with pirates, like, yeah, I'm not living in that age, and as I was growing up and getting older and started working in IT, I figured out we actually live in the most exciting age of human history. And if you look at the things that happens around us, and what is out there, what's all these startups are doing, and what's happening with AI and such, like, technology is advancing super fast, and there are so many those emerging technologies popping up every day, and AI is definitely one of them. And it develops super quickly, and it's I find it super interesting and exciting, and did some projects with that. I'll show you today some stuff. I'll show you the custom vision, and I think it's really interesting what you can do, and the way that Microsoft approached that. This simple interface it gives you to work with super complicated technology. It's really nice. So this is my favorite slide when I talk about AI, and this is a dog, right? And now imagine that you have standard traditional development, and you want to detect, like, is this dog or not? It would take a lot of lines of code, a lot of algorithms to write to figure it out. And then the question is, like, okay, but what if he raised the ears or turns on the side? Like, how would you adjust that in code? And this is where AI comes in and gives us so many opportunities to solve this in a pretty simple way. We train the model, which is, you can imagine it as our brain. You show to this model some pictures and say, this is a dog. And you can show it some other pictures and say, this is a cat. And after some training, you can use this model in your applications to be able to tell, is this a dog or a cat? This is a super simple example that you'll find a lot of tutorials on the internet. But that's where it begins. And this is the basic things you need to understand to be able to implement AI in your applications. So For example, imagine some industry where you would like to know what kind of parts are there on the moving track or in some box. So you could use this visual recognition to figure out different parts by training some model to be able to distinguish between those. So we said we will talk about Microsoft Azure Cognitive Services, and I will show you this web page. And what Microsoft say over here is a family of AI services. And there is a really lot of services that you can use to build intelligent apps. It is super simple, and Microsoft divides it in 5 categories: decision, language, speech, vision, web search. So decision-wise, we have anomaly detector, content moderator, some metric advisor, personalizer, and so on. We have language services like reading, Q&A maker, text analytics, translator. That is natural language processing, like speech to text. You want to be able to enable microphone, user speaks, you convert this into text, and you want to do it the other way, from the text to the speech, so user can hear something. There is also options to do the translation. We have a web search and APIs there. We have a vision, which we will talk about today, and that's something I really like. I'm a visual type. I always draw something when I'm explaining, and I really like how images can be processed in an AI way. And over here we have computer vision and custom vision, which we will talk about today. I will show you the both, and you can explore some other options there, which is face, form recognizer, video indexer, and so on. So regarding computer vision, if you open this link, you can see this page. That is an AI service that analyzes content in images and videos. And over here, Microsoft will show you one example, how it looks like, how it processes the image. So this is some image of some train station. Train is in movement. Those 2 persons are in movement also. And AI vision recognized and marked with the rectangles over here. What does it see? It sees some subway train in this big rectangle. Over here, it sees the person. And here is another person. So no matter that train is blurred and persons are blurred, it still does a pretty good detection, right? And on the right side, over here, you can see it in more details, what was actually found in the picture. So you can see there is some rectangle with position X and Y, where it starts on the image. What is the width and height of that rectangle to be able to mark it. And then it is an object, person, and confidence about it is 76%, right? Then it see another person, subway train, and so on. Model that is used over here in the background is model for general use. So it will recognize some 1,000 different object categories. Where custom vision comes in is when you want to recognize something custom, something that is not in these 1,000 categories, and we will show that. I just wanted to show you this computer vision, how it works with the picture. So let's use one custom picture. Let's take something from here. I'll copy the link of this puppy, and over here there is an option to use image URL. So I will paste URL, and hopefully this file type is not supported. Let's try another one. So we will paste, maybe I need to save it. So on a desktop, I'll save the picture dog. And over here in computer vision, I will upload the picture from my desktop, the one I just saved, dog, and try to process it with computer vision. And yes, so it, as you noticed, it's completely random picture from the internet, and it managed to recognize this dog pretty accurately. And it even recognized that it's terrier dog, and marked frame also pretty accurate. Maybe the paw is a bit out of the frame and ears, but this is something that with additional pictures, similar pictures can be trained, and then it would recognize the picture. So getting back to our example, this is a dog, and spreading those ears and using traditional way of programming, you can imagine that it would take a lot of effort to actually develop something like this. So we are getting to the, we said computer vision, we are getting to the custom vision, and which will easily which will allow you to easily recognize some custom pictures and detect what is inside of them. I put 2 links over here. Custom Vision AI. This is a web page where you can, Microsoft created with super simple user interface where you can train your models for classification or object detection. We will get into that. And I put here a link on GitHub on one repository. After the talk, I will upload example over there, so you can check Global AI on Tour. So over there, I'll put the images we used in this talk. Okay, so we can close the computer vision and go to Custom Vision AI. At the moment, I'm logged in automatically. If you land on the page, you will see one big sign-in button where you can click and connect with your Microsoft Azure account. If you don't have a Microsoft Azure account, you can register for one free and use this with some limitations of free credits that you have. Okay, so we want to create a new project. Over here, I'll click on the new project, and interface will pop up that will ask us, okay, what kind of project we want to create, and to set up some parameters over there. For the use of this project today, what I have is actually pictures of Lego minifigures. So I have minifigures like Superman, I have Batman, and some other superheroes, Harley Quinn, Green Lantern. And we will use those pictures to train custom vision for a reason, because this is not something standard models are trained with. So in my case, those are the Lego minifigures, but it could be something from different car parts if you work in the car industry, for example, or many other things that you want to make custom AI detection. So let's give a name to the project, Global AI Tour. And over here, we will say this is Lego classification. For the resource, I can use some existing resources, or interface automatically gives me option to create new resource. What is this about? In Azure, everything you do, you group into resource groups, right? Resource groups contain your resources, and those are different services that you use in your project. So through this simple interface, there is no need to go to Azure portal. Through the simple interface, you can create a new resource if you want. Let's call it Lego Global AI. We can choose a subscription, pay as you go, for example. We can also create new resource group. Let's call our resource group Lego Global AI RG as resource group. We can pick location. For me, the closest location is West Europe. I create the resource group, which my rights are changed at the moment, so I'll have to use the existing one. But through this interface, you can create this easily. I'll use the existing resource group. I haven't tried to create it, so didn't know this was changed. I select classification or object detection as a project type. So what does it mean? Classification is able to tell what is the most represented picture, what is the most represented object in the picture vision is seeing. So if there is a dog and the cat which is somewhere in background, it will figure out, okay, this is a dog because dog is in front, right? And with object detection, we can figure out like where exactly in the picture is this dog located. That's what you've seen with the computer vision when it marked the exact location. So classification will say, okay, I see that this picture is about the dog, if dog is in front and largest object in the picture. And with object detection, you will get the exact location and position. We'll do the training for both. There are two classifications. When we select classification, our object detection options will change. We can select for classification two types. There is a multi-label and multi-class. Multi-label means there are multiple tags per image, so we can tag the image with cat and dog, and to detect are the both tags in the image. But to keep it simple, we will use single tag per image, and that is multi-class. There are also domains. Domains means that models are already trained, optimized for some usage. So there is a general usage. There is a model which is prepared for detecting food. For example, you are making some Instagram-like app where users will take pictures of food. So maybe you want to train this model with some additional dishes to be able to recognize it, and then you can post that, and AI will recognize, okay, which dish we talk about. Also for the landmarks, retail, and there are the compact models which can be used on the iOS and Android platforms. So those are the lightweight models as it's written over here. We will use the general model. So I will create the project. And as I created the project, I entered this super simple interface. On the left side, I can see the iteration, switch between tagged and untagged images. In the middle is the content I will be working with. At the moment, there is no content. You can see the message. You don't have any images here, add images. And at the top, I have some options regarding the training, performance, predictions. We will get into all this. First of all, we need some images to train with. So I will click Add Images. And I said that I prepared pictures of our heroes. So over here, I have several folders with different pictures. And let's take, for example, Batman. That's our first hero we will classify. As you see over here, I have 9 pictures of Batman. I will select them and click Open. The pop-up over here say to me 9 images will be added, and I can immediately tag those images with specific tag. So let's tag it with Batman, right? Because Batman is in those pictures. We select upload 9 files. It will take a few seconds so it can be uploaded, and it will be shown in our dashboard. I click done, and here we can see, okay, this is the Batman. You can also notice the tags. At the moment, I'm in tagged. If I haven't selected the tag, images would appear in untagged area. So over here, I can switch between tagged and untagged. I can also see that I have Batman that is in 9 pictures over here. The way I took the pictures, you can notice there is a Batman is standing on the Lego brochure. And the reason for that is to have different background on those pictures. I could took it also on the white table, and it would look nice for us, easier to recognize. But what we want to do over here is actually to bring some noise to the background for AI to be able to figure out what is same in these images, like how these images are look alike, right? So that's why I'm using the Lego catalog in background. Okay, so we have Batman now, and we would like to have another classification, so another tag, and we'll switch to untagged, add images. We could do the same with option add images over here, and we will, for example, take the Superman. Superman, I also have 9 pictures here and some additional pictures in the subfolder. So I will select those 9 Superman pictures, click open. I will call this tag Superman. I'll say upload 9 files. Takes a second, and those files are uploaded. Done. You can see Superman over here. Pictures were taken in the similar way, right? If we select both, we can see all pictures over here that we uploaded. For one of them, preview failed, but it should be there. Okay, it works nicely. So we prepared our pictures, and please note over here that number of pictures we work with, it's super small. Basically, to train some model to do really good recognition, you should prepare many more images. But even if we have only 9 images per tag, for our tests, it will work fine. So what we need to do now is we need to start the training. I will click train and select the quick training because we want to do it quickly. We will not adjust our parameters and such. We click train, and our model is training in the first iteration. So the training started. Usually it takes like few minutes to get our model ready. And as it becomes ready, we can publish this model, which means we will automatically get the prediction URL and key to access this model. So now process of training is happening. Model is taking these input images and trying to figure out difference. Okay, those are Batman, and the other ones are Superman, right? We will get the prediction URL at the end in the key, and we would like to use it from our applications. So simplest way to do that is, for example, some web page. Just a second. Web page. So I have example over here, and I will open it in text editor to show you what it is about and how it works. So this is one HTML page, consists of head, where we include the jQuery script. We have one custom written script, and we have the rest of the body where we have some text, image to analyze. After that, we have input box that is just the text, right? It's called input image, same ID. And it has value to one of my GitHub repositories to some picture over there. We can copy this link to see what is this about. And paste it over here. As you've seen, probably our model is still training. So not to wait for it, we go with code. You can see the picture of Superman. This is not one of the pictures we use for training. So this is different picture. And we want to classify it. Pictures we use Superman was 1 to 9. This is A1, like test. So we want to classify it. Our model never seen this picture, and we would like to know, is it able to tell this is Superman or not? So we have text, image to analyze, we have input box, and after that we have a button which say process image. So it will call some JavaScript function that will process this image. Title of button is classify image. After that, we have one div, which is basically divided in two parts. First part is JSON output. Our classification will return the JSON response, and we would like to see how this response looks like. So we have one text area that will be response text area that will be filled with the text from the JSON. The other part is image, where we will display the source image. Because we are loading the image from URL, we would like to display it over here and show our response over here. As you see, JavaScript is triggered with process image. So before I explain you how this function process image works, I will open this example and show you the page. So this is what we spoke about. We have image to analyze. Let's follow our code. Image to analyze. We have one input box that has a value linked to the image. That's here. We have button classify image. That is our button here. And we have two parts, one text area and one where we show source image. So this is where response text area, and this is the source image. If we go back to our code and take a look at the JavaScript now. So this is where we will invoke our prediction URL, and we will try to classify this image like what does it see. So first of all, to use our endpoint, we need to define the value, something we will find in the interface once model is trained and published, and the prediction key. we will say that our that our source image will be set to source image URL. So that is the value of the input box over there, and this is how we will display the image to show on the page. After that, we are doing the REST API call, and we need to define in our header some things that content type is application JSON, and request header prediction key, set our prediction key. That's the value we will enter over here. It is a post. We say for the data, we are sending the URL and our URL from input box. So we make the call, and once call is done, we want to show formatted JSON on web page. So response text area value, we will say this is JSON value. We use JavaScript function stringify to display it. In case of failure, we have some errors to display. If I go back and check the model, it is rain now. And over here we see three values: precision, recall, and AP. So in order to explain you that, I have a slide over here. So precision is the number that will tell you if a tag is predicted by your model, how likely is that to be right. Recall, this number will tell you out of the tags which should be predicted correctly, what percentage did your model correctly find. And MAP, that is mean average precision, and it will tell you the overall object detector performance across the all tags. We trained the model once. This model never used some images to validate itself, so everything is at 100%. It will work great because it was never tested. Later on, we add those test images and try it out, and we can repeat the training and continue with this model to improve it further. Okay, so I click the publish. We want to publish it. I will use existing resource since my rights at the moment doesn't allow me to create a new one. So I'll just say publish. And over here, we see that button changed into unpublished, and button prediction URL became enabled. We click prediction URL, and we get some interesting input. So this is something we've already seen in our JavaScript, right? We need to set prediction key header. We set over there content type to be application JSON and body to URL, the path to the image we want to process. You could, this example I'm giving you is in JavaScript. You could use it from any other programming languages. It's just simple REST API call. You send where the image is located, model processes the image, returns you the JSON value. You can parse the JSON and use values from it. Okay, let's copy this URL. And in our code, we say endpoint needs to go here. So we save the endpoint. And we also need the prediction key, right? Prediction key. And paste it into here. This prediction key and this endpoint is used when the REST API call is made. So we have the prediction key here set in the header, and URL is set to the endpoint. I will save this file, go back onto the web page, classification. I will refresh the web page since we made the changes. And what should happen now when I press the classify image is basically this URL will be taken. First, we will set the source image to the source image. send call to the vision to classify our image, and we will display JSON in the left response area. So click and classify image. Now we display the image. It takes about a second to get reply back. And what we see over here, we got some values. So we got ID, project, which iteration it was, when it was created. And we see some predictions. There is probability 99% that this is Superman, and also gives you a negative probability of 0% that this is Batman, right? So our model is pretty sure that this is Superman. If we go back to custom vision and click on the training images, we can see that there is no such image for the Superman we just used, right? This is taken picture from the angle of all those Supermans, and this is from the top. But obviously, because of the S on the front, it's easy to differentiate between these other images, which are Batman in our case. I think this is super great and super simple, because with few lines of code, if you take a look at this, so you basically just defined the endpoint key and made one API call, you get the result that is telling you, okay, is this a Superman or is this a Batman? You could use it in a similar way with the video feed. So you could classify what's happening on the fly. I'll show you some examples regarding that a bit later. This is classification, right? So we would also like to see how object detection works, which is not a bit more advanced, but it can tell you like where exactly is the Superman in this picture. So let's go back to our projects, and we will create a new project. And this one we can also say it's global AI tour, but this will be object detection. And yeah, we can enter object detection Legos. I'll use the resource group that I have, and this time I'm clicking the object detection. Domain I'm using it will be general. Some other domains we have is logo recognition, which is pretty much also used in the industry to figure out like okay, which logos are on the boxes, so you can sort them out easily, or recognition for products on shelves. You've seen probably a lot of those mobile applications that's already assisting you in the store and giving you some kind of suggestions, recognizing the product and maybe comparing it to other stores to give you some suggestions, like if you go to other store, it's 10% cheaper over there maybe, or this is the perfect price, you are on the right place. For our use, we will use the general domain and we'll create the project. Interface is the same. We see that we are in the right one over here on top left. That is our object detection. And we would like to add images. One limitation regarding object detection, since it's a bit more advanced, the minimal number of pictures you can have in your training dataset is 15. You need to keep that in mind. And even though it requires a bit more than classification, it is still such a minimal amount of pictures that you'll be using. So for really accurate vision detection, you need thousands of images. I will open those Supermans, upload. 9 files I used before. Done. As you probably noticed, it didn't ask me like to tag them immediately. And what we can see here, we see one red dot, and those images are now untagged, right? We said we need 15, so we'll add some more images in the subfolder additional. We have some more, so let's include first 7 images. Open. We can leave 3 more for training just to test how it works. Okay, so we are still in untagged images. Let's tag them. Click on the Superman. We can click over here, and it's automatically trying to adjust this frame by use of some pre-trained algorithms. That makes this UI even simpler. And now we mark where our Superman is, and we say, okay, this is a Superman. You can see it's tagged now when I put the mouse over. If I move mouse around, the picture is trying to recognize some other things in the picture, but we are not interested in that. So we will just move on and continue with tagging our other pictures. We try, when we do that, to adjust this frame as accurate as possible. That is that example with the dog and ears you've seen earlier. So you want to be like really precise here, if possible, if that's what you needed. But for real precision, I'm saying you still need a lot of pictures. In one company I worked for, we had around 400,000 pictures. It was application like Instagram for tattoos, right? And users were able through the mobile application to upload pictures and to tag them and write some comment with them. So standard, imagine it as a standard posting on social media, Facebook, Twitter, or something. And based on the tags, hashtags they were putting, we were able to tell about 100,000 pictures. Okay, this is what we see it is, but for the remaining 300,000. We had no idea, and we wanted to build some AI-powered suggestions, like to use those images and to make our suggestions feed like a Discover feature. I think it's called like that in Instagram now. I really don't know out of my head. I'm not a heavy Instagram user. But the thing is, we wanted to build some feature and to use those images. So what we did, we classified our images, this 100,000, we knew what it is inside of them, and trained the model and tested it on the remaining 300,000 pictures, and we figure out it's really capable of recognizing the pictures, like figuring out which style of tattoo it is. It is like in general, tattoos are divided in some 13 styles, like tribal, old school, and so on. And this was great result. But then we figure out, okay, how we can train it to improve it more. What we can do, and we decided to train the model in a way that we do the segmentation. And segmentation is basically figuring out, like in the image, where is something located. So first thing, we try to find in the image where is tattoo located. If someone took a picture of whole body and tattoo is, for example, on the hand, on the arm or something, so we segmented the picture, figuring out, okay, here's the image, and then we did classification on that part of picture. Project was recognized by NVIDIA, featured over there on their developer portal. It was also published on some popular websites like the Next Web and such. Okay, telling you this story, I managed to tag all the pictures. Untagged is empty. Tagged, yes, we have them over there. Now we want to train the model, and we will select the quick training, and our training now started. It will take probably a bit more to train, so not to wait on that. I wanted to see to show you some of my personal blog posts, and this is on Dev2. You can find my posts over there. One blog post where I explain like what does the computer vision see, analyzing a local image with JavaScript. Similar to thing we just did, right? But in this blog post, I'm using the camera, and I'm explaining, okay, how to enable the camera, and to take a screenshot. I'm taking screenshot like every 5 seconds, and to display it over here, and to take the description from computer vision. There is one property in computer vision, that dog is open. Still, that's good. So if you scroll this JSON you are getting back, you can see there is a description text, a dog sitting in the grass. Okay, it's not quite sitting, but we can imagine it's hard to tell, right? So what this blog explains is how to do the similar thing, take screenshots from the camera and show it on the page. It's using the same things we are looking at now, right? Just added the camera feed on top, and we tested it at the office. This is my friend from work, Arlon, and the detection it made is a person flying through the window, which is kind of funny result, right? But if you think about it, like there is a glass conference rooms behind him, right? And he's in the move, passing by, and picture of him moving is a bit blurred. So AI figure out, okay, it's person in the moment, and there are some windows, so maybe he's flying through the window. It works really nice, and it's fun to describe the pictures, and something that you can use in your applications also. For example, there is also whole code and explanation step by step published over here. Some other blog post I can see on this topic is where should we object detection with Azure Custom Vision. I do a lot of projects with these Legos because I find it super fun. I am really like this, and I have my son, he's 30 now, and not playing so much, but we still assemble some things. So this example is trying to find the Chewbacca Lego minifigure in on the board where there is a lot of Lego minifigures. If you take a quick look, it's really probably hard to find him, and explains you step by step, okay, this is how you create your project, and this is how you do all the steps needed, including creating resource group and resource if needed. And adding your pictures, you see that I use the same logic over here, taking photos on the Lego catalog, marking the Chewy, what we just did in our example with the Superman now. It is training. So we mark the Chewy, we say, okay, quick training, get some result, and then we see the interface where we can test the images. And that's what I will show you now in a few seconds, hopefully, as soon as it's trained. So you can select the pictures and you can try it out. And afterwards, with those pictures you use for the prediction, you can also add them to the model, mark where exactly result is, and you can retrain it, improve your model to be more accurate, to give you better results. So first time I tried it out, On this picture over here, I was not able to find it correctly. You can see 4 locations, right? But none of them is this Chewbacca from the Star Wars. So what I did is I added more and more pictures, and after few iterations, I was able to find Chewbacca here with accuracy of 40.8%. So in the picture, it is over here. Even though it looks this accuracy is small, there's a lot of many figures on this picture, and even for you it would take few seconds to find where exactly is it located. So that's a kind of good accuracy and can be improved even more with more pictures. So we got our model trained. We had the Superman with 16 pictures. We got some results, and with the same procedure, we could publish this and make a prediction URL. We could utilize it in our code the same way. But what we want to do over here, we would like to use some features from the UI and make a quick test. And we can select the image URL here in quick test, or we could browse for local files, which is something I will do. And over here, we included the first 7 pictures, but for example, Superman A8 is a picture that our AI haven't seen. So let's open that one. And it at the moment it is using model trained in iteration 1. When you have more iterations, you can select them and see which one performs better. Maybe some pictures you added were not so good for AI to understand better. Maybe you confused it with something or marked something wrong in your tagging. So here you can go back and forward and to figure out how it works. And in our prediction results, we see over here, our Superman is detected with 92.4%, right? Which is pretty high accuracy. Okay, we can say, yeah, this picture is similar to the others and there are no other Lego minifigures in it. So maybe to try with some other picture, we have tests over here. And for example, we could maybe try it out with Superman and Green Lantern. Now, both of them are marked because they have the similar shape. And we did use minimal number of images to get our model. But if we take a look, Superman was recognized with 89.2%. Frame is also pretty much accurate. It was me doing it, tagging quickly and giving you some examples. And the Green Lantern is 68.7. So if we take the higher probability from this picture, that is our Superman, right? So how could we improve our model? How to train it more and such? We could use option to add images over here. So we can add additional images and train it such, but we could also use images from prediction. If you put the model in your production, right? Or here in prediction, you can see how it was used and which values it got. So if we select, okay, this is a Superman, right? And this one, it's not a Superman. So we'll use this one. It will take that image, throw it into the training images, and you can retrain your model and to improve it further. And with this, we get to the end of our session. This is another example I tried out earlier. Like you see how many of them are marked over here. But like Superman is still marked highest with 74%, and 44% is some other frame. There, after the session, I'll upload the files to the repository. If you have Lego minifigures, you can use your pictures. You can use anything you like around the house. And you can use in this folder, you will find several different, so you can try out how it works. Okay, so with this, we are getting to the Q&A part, quick one. So my question
Hey, Goran.
Yeah, hey, are there
So
any questions?
Yes, so we have these questions for you. First of all, Utkal Techies Forum wanted to tell you that it would be great if you can share a bit on how to start a career in the field of AI and ML for the people who want to get involved in this field and pursue it for a role, a full-time role.
Okay, so if we talk about AI, it's a field of science that exists for a long time, right? But in the last few years, it kind of went super popular for the reason now we have big data, and big data is required to train AI models and to start with them. And that's why it's super popular, and we see it popping up everywhere, and many different use cases and such. Learning how these models really work, we could talk about that for months, some session. But the thing is, there are such a super simple interfaces like Azure is providing over here. And I would really recommend trying to learn for AI certification from Azure. Over there, you can go through all the services that Azure is providing and get to know them, and you will know this AI on a high enough level to be able to use it in your work and to actually start your career.
Okay, so next question is from Abhinav Prakash. Can we do computer vision interpretability using Azure Custom Vision API?
So use it in both. For computer vision, you have one endpoint, and for custom vision, you create some your endpoint where you detect the images. You could combine it and process image with both and use the result. Now I'm not sure like which use case he maybe had in mind, because computer vision is something I would use for the general use. And for example, if I have some application, let's say it's social network, right? That's the easiest thing we all can imagine. Users are uploading pictures. We want to validate, okay, if it's a profile picture, like is the face inside? Do we see that person, right? Or maybe he's uploading picture of chair, and we don't want to allow profile pictures that are chairs. I think LinkedIn have a strict restriction regarding that profile pictures should be faces, right? Profiles, real persons. So that is one example how we could use computer vision. We can also detect, like, is the picture appropriate, figure out some description and such. This is more for that use. And with the custom vision, I would maybe try to detect, okay, is there some specific logo in the picture? Is it let's say you organize some game where users should post pictures with your product, and you want to validate it automatically without looking at each picture and saying, okay, this is a correct one. So you could process it with a custom model and figure out, is your logo in the picture? If logo is there, that person is probably showing your product in some way. So it's about use case, yeah.
Okay, so next question is actually my question. So it is, if we put the images of a twins, Azure Custom Vision will be able to figure out the differences in their faces or not?
that would require really a lot of training. And because, yeah, twins are almost the same, but there is still always some small difference between them. And yeah, we need somehow to figure out, okay, this is the difference we are looking for. And otherwise, we could have like this picture with Superman and Green Lantern. Both things would be marked and would say, okay, I'm 95% sure over here, and over here I'm 90%.
Okay. So Goran, we are as well having a prize from Pact, our sponsor, for the best question that shall be asked for the session. So to whom would you like to give that?
Well,
you have two questions.
I always appreciate when people try to work on their career, improve their knowledge and such. And first question about how to kick off the career, I would say that I like.
Okay, so Goran, there's one more question for you. Can we use custom vision plus Azure IoT Edge on Raspberry Pi?
Yeah,
Raspberry Pi, that is.
I have one project that I haven't shown you. We used IoT Edge to build one rover that is moving around, and over there we were taking the images with NVIDIA Jetson Nano, and also we needed to know the location of the rover, where is it positioned. So we combined also the phone to get access to internet and to get GPS location. And with this combination of pictures, we sent to the Vision API and process it. I can put it in the GitHub repository link to that blog post, like to see over there, like one interesting use case. We built it in a company I work for, Stratitech. There was a lot of developers and other people included into projects and building something cool. Yeah.
I'm sure Swastik would reach out to your GitHub repository. So let's just moving forward. We have no more questions for you. Okay. So thank you so much, Goran, for joining us to our event. And thank you so much for such an insightful session.
Thank you. It was my pleasure.
Thank you. So with this, we come towards the end of our event. Now, I would like to call Ashirvad Satpathy, the member of Organizing Committee, Utkal Techies Forum, for the vote of thanks.
Hi Shubhangi. Hi, everyone. This is Ashirvad here. And thank you for attending the session and making it a really great success. And I'd like to thank all our speakers, all the ones, who stayed out throughout the 5-hour sessions. It was really helpful. And trust me, this is not the end. And we are going to have more events lined up. We have one on January, that is .NET-Conf Bhubaneswar. Do stay tuned for that. And secondly, I would like to thank our sponsors, Pact, Microsoft, then our speakers, even Akanksha, Priyansha. Then we have Jamie, then we had Håkan and Goran. And finally, our committee members and the curators, starting with Shubhangi, Alok, who managed the whole session throughout the day. They were there behind the stage for the last 5 hours or so. Then we have, our committee members from UTF, Tanmay, Nirmal, Tadit, and Subendu, and me. And we have been, coordinating with, all the speakers and everyone to organize this event and make it a success. And finally, I would like to thank 3 other members, 2 from the global AI community, William and Hankin, and then Hanks and Nandeep, who is also a part of the Pune Tech community, but organized the Global AI on Tour Pune event. So they have been really helpful with me, in setting up all these things. And that's all from my end. And I'd just like to share my screen and show you people a bit about some of the competitions that we are organizing for you, so that you can get some goodies and get everything out of this particular event. So this is the learning path. These are all the learning paths that we have. Vivek made it for us, and you just need to complete any one of them and post it on Twitter. You'll get, after completing it, the badge would be there. Shubhangi has already showed it to you people, but just for the sake of showing, I'm showing it again. So go to achievements, you'll get your achievements. So you can share it over here. You can just take a screenshot of that and share it with your friends. Just make sure that you what do you say? You tag Vivek and Arko in that. I mentioned it in the channel's live chat. You can have a look over there. It's also mentioned in the mails. And secondly, do complete this quiz. The exam vouchers that we are giving is you can use it for any Microsoft exam, whether it is related to Azure or it is for Power Platform or Dynamics, or else you want to give any of the MCSA or MCSC SD certification, which are going to retire in January. If you want to take it now, you can take it using these vouchers. So don't miss out the opportunity and try to complete these exams by 8:30 p.m. today, because after that this link won't be working. And in case you want to host any sessions for Microsoft Reactor Bangalore, or else you want to put your sessions in Microsoft newsletter, then he's the guy to reach out. And that's all from my end. Thank you all. Shubhangi, would you like to add up anything?
I would like to thank all our viewers and share your screenshots of the event on your social media and mentioning our hashtag and mentions so that we can reach out to you. Thank you. Take care. Stay safe. Bye-bye.
And guys, just one more thing. You're going to get a surprise in your mail. So we didn't mention it yet. You're going to see it in your mail. So look forward to that. Thank you. Have a good day. Stay safe. Take care.
Thank you, everyone.